Welcome to Backspace Academy. We're currently at the start of all the pathways for AWS certification. This course is essential knowledge that is required for all AWS certifications. So it doesn't matter whether you intend to sit an associate level certification such as the Solutions Architect Associate, Developer or SysOps Administrator Associate, you still need to complete this part of the pathway in order to gain this essential knowledge before proceeding any further. AWS has a massive amount of products and services, so before we start using them, we must first understand what this massive ecosystem is and how we can use it for different applications and industries. In this introduction to AWS, we'll start by looking at the AWS global infrastructure. Then we'll look at the different cloud computing models that can be utilized by this global infrastructure. We'll then move on with a broad overview of most of the AWS products and services, and throughout the course, we will reinforce what you have learnt through hands-on labs of common use cases. And of course, along the way, we'll also have review questions. So, without any further ado, let's get into it. So what is the AWS cloud? AWS has invested billions of dollars in resources that are distributed across the globe, and the use of those resources is shared among thousands upon thousands of AWS account holders. Now, although those resources are shared among those account holders, the accounts themselves are completely isolated from each other at the hypervisor level. You also have the option of your own dedicated resources if you wish. You, as an account holder, can have on-demand delivery of AWS resources on a pay-as-you-go pricing model with no upfront costs. You only pay for what you use. The more you use, the more you pay. The less you use, the less you pay. When you don't use it, you don't pay for it. When you use it, you pay by the hour, or the minute, or the second, and some services even provide billing by the millisecond. Now that provides some really good economies of scale because the cost of the infrastructure is shared across thousands upon thousands of account holders. If you're a large enterprise, that is great because you don't have to worry about the capital expenditure of your own infrastructure. And you don't have to worry about the maintenance staff to support that infrastructure. Now that infrastructure is organized according to a range of different product types. If you want to use those resources for pure computing power, AWS can do that for you. If you want to use AWS to store data, AWS can do that for you as well. If you want to run a database as a service, if you want a relational database, a NoSQL database, a graph database as a service, AWS can do that for you. And they'll do that on demand on a pay-as-you-go pricing model. The AWS global infrastructure is massive and is divided into geographic regions, and those geographic regions are divided into separate availability zones. As you can see, there are lots of regions distributed throughout the globe. For this course, we will be using the North Virginia region because that is the largest region and supports all of the available AWS services. If you're using a smaller region, for example, Mumbai, you may encounter problems if it doesn't support all of the available services. The AWS GovCloud is located in the US West Coast and is specifically for US government organizations. There is also a secret region, and I can't tell you where that is because it's a secret. That region is specifically for US government intelligence organizations. And in case you're wondering, yes, the CIA is a customer of AWS. Your choice of region can depend upon a number of things, and you may want to have the lowest latency, and you want your server to be located as close to your customers as possible. But you may also want to minimize costs. For example, I'm located here in Australia, but I mainly use the North Virginia region because it's cheaper for me. You may also want to locate your server in a totally different country for regulatory reasons, or you may want to be located in your country for regulatory reasons. So there are a number of factors to take into consideration when selecting a region. Each region is divided up into at least 2 availability zones that are physically isolated from each other. This provides business continuity for your infrastructure if it is distributed across multiple availability zones. If one availability zone goes down, the infrastructure in the other availability zone will continue to operate. The largest region, US East, North Virginia, has 6 availability zones, and the availability zones are connected to each other through a high-speed fiber optic network. Local zones are located close to large cities, industry and IT centres, and can provide the lowest latency within that specific area. For example, if your business is located in Los Angeles, you may want to have your infrastructure located within that local zone. Local zones operate as an extension of an AWS region and also have multiple availability zone capability for high availability. There are over 100 edge locations that are used for the CloudFront content delivery network. CloudFront can cache your popular content, such as images and videos, and distribute that to edge locations across the globe for high-speed delivery to your end users, no matter where they are located. And it'll do that with very low latency. It also provides great protection against DDoS attacks. AWS Wavelength deploys standard AWS compute and storage services to the edge of telecommunications carriers' 5G networks. This enables developers to build applications that deliver ultra-low latencies to mobile devices, because those applications will be run at the service provider's data center without having to traverse multiple hops across the internet to reach their final destination. This is great for connected vehicles that need low latency for environmental analysis or critical data, for interactive live video streams and live television broadcasts, and also for real-time gaming on mobile devices. AWS Ground Station is a fully managed service that lets you control satellite communications, process that data that is received, and scale your operations without having to worry about building or managing your own satellite ground station infrastructure. Ground station antennas are located within the AWS global infrastructure. The way it works, contacts, which are simply reservations for a ground station antenna, are scheduled for when a specific satellite is in proximity to that specific antenna. By doing this, you can save up to 80% on the cost of your ground station operations by paying only for the actual antenna time that is used and relying upon the global footprint of AWS ground stations to download data when needed within proximity of that satellite. Kuiper Systems, which is a subsidiary of Amazon, will be launching a proposed constellation of low Earth orbit satellites, delivering high-speed internet via high-performance customer terminal antennas. AWS, and of course other competitors such as SpaceX's Starlink, will provide high-speed, low-latency internet connectivity to unserved and underserved communities around the world. This is absolutely fantastic as it will provide high-speed internet to third world countries, allowing quality education and globally competitive provision of services, and this will greatly reduce global inequality. It will also extend low latency access to the AWS cloud from all areas of the world. For example, you could have a mining operation in the middle of the Australian desert with a high-speed connection to the AWS cloud. Imagine a researcher in the Amazon rainforests who is finding new viruses and medicines being able to run a powerful analysis remotely in that environment. The opportunities for this technology are endless. Cloud computing allows developers and IT departments the ability to focus on what matters most and avoid costs like server purchasing, maintenance, and ongoing capacity upgrades. There are several different models and deployment strategies that have emerged to help meet the specific needs of these different users. Each type of cloud service and deployment method provides you with different levels of control, flexibility, and management. Looking at cloud computing models, the first one here is infrastructure as a service. Infrastructure as a service, it contains the basic building blocks for cloud IT. What that means is that this is nuts and bolts stuff. So if we want to launch a Linux server and we want to manage that Linux server ourselves, that is how we would do that as infrastructure as a service. And we could do that using the Elastic Cloud Compute or EC2 service. The next level is Platform as a Service or PaaS. And that's where AWS will take a little bit more control over the underlying infrastructure. AWS manages their underlying infrastructure and the hardware and operating system normally. And a good example of that would be the relational database service. And in that service, AWS, they provision all the operating system, the server, and everything to run that, but you still need to do the high-level administration of that database. Finally, we've got software as a service or SaaS. And that is a complete product that normally runs inside a browser, and it mostly refers to end-user applications. A good example of that would be Office 365 or Salesforce.com. You'll hear another term used a lot within AWS, and that is serverless computing. That allows you to build and run applications without having to think about servers. You don't need to provision the server yourself. AWS will do that for you. It's also referred to as function as a service or abstract services. Examples are the simple storage service where we create a bucket and we put objects or files into that bucket. We don't know what's behind that bucket. Obviously, there's going to be an operating system, most probably a Linux operating system, a file server. There's going to be hard drives. We don't need to worry about that because AWS, they're going to look after all of that for us. AWS Lambda is where we can run code in the cloud, again, without servers. You just provide AWS your code, and AWS looks after everything for you. DynamoDB is a NoSQL database in the cloud as a service. And Amazon Simple Notification Service that can send out notification messages to your users, and it can do that without you having to worry about managing a server. There are also different models for deploying cloud computing. In a completely cloud deployment, we could fully deploy our application in the cloud, and all parts of the application will run in the cloud. The next is a hybrid deployment, and that is a way to connect infrastructure and applications between cloud-based resources and existing on-premises resources. This can allow an existing on-premises infrastructure to extend and grow an organization's infrastructure into the cloud while connecting those cloud resources to our remaining on-premises infrastructure. It is also possible to run AWS infrastructure on-premises as part of a hybrid architecture. AWS Outposts is a fully managed service that offers the same AWS infrastructure, AWS services, APIs and tools to virtually any on-premises facility for a consistent hybrid experience. And finally, deploying resources completely on-premises using virtualization and resource management tools such as VMware is sometimes referred to as the private cloud. The AWS Management Console is a web-based interface to AWS, and we'll be using that throughout the course to access AWS services, and you'll also use it to monitor your costs. You need to have an account to access it, but once you have an account created, you can access it by simply clicking on the My Account menu from the AWS website and then selecting the Management Console. There's also an AWS Console mobile app, and that is great for tablets and mobile devices. You can also access AWS resources through the many software development kits. This allows you to create applications that use AWS as a back end. There are software development kits for all the major languages, and there's also a mobile software development kit. It's also possible to access AWS with direct HTTP calls using the AWS REST API. You can also install a command line interface on your desktop, and that will allow you to remotely connect into AWS and also be able to create and run scripts to automate a lot of the processes on AWS. The AWS website is located at aws.amazon.com. What I want you to do now is to go to that website and bookmark some pages off the website. The first one is the certification page, and that will have links to everything you need to know about the certification process. So if you're not sure about what certification to do, or you want to know how to schedule and sit an exam, that is a place to go. The next one is the documentation page. Throughout the course, we will be referencing the documentation for the services on AWS. So that is a very important link. And the exam, it's going to be testing your knowledge of a lot of this documentation. AWS also has a site specifically for white papers, and in that they discuss technical issues and use cases for AWS. The products page gives a really good overview of the main products of AWS and a description of those, and it's a really good one for preparing for the Cloud Practitioner exam. And finally, the new products and services page, and that will keep you up to date on the latest things that are happening in AWS. Okay, let's get started with AWS. First off, go to aws.amazon.com, click on the orange sign up button in the top right-hand corner, and complete that sign up process. You'll need to have a credit card to sign up, but don't be too concerned as there is a free tier available for a 12-month period, and most of the course will be operating under that free tier. We can also set up a billing alert to alert you if you exceed your budget. For example, we can set up a $5 billing alert to notify you if you exceed $5 for the month. Once you have created that account, you can then get into the Management Console by clicking on the My Account menu and then selecting AWS Management Console. Coming up next will be some hands-on labs on AWS services. So make sure that you download the lab notes that come with this introduction to AWS, and you'll find that in the resources of this video. And do that before proceeding any further. And once you've done that, I'll see you in the next lecture. Welcome back to Backspace Academy. Here I am in the AWS website. Now, the first thing that we need to do is that we need to create an AWS account by clicking on the orange button there in the top right-hand side. Once we've done that, we can supply a valid email address and a valid credit card. Don't be too concerned about that, because for accounts that are less than 12 months old, you can operate under the AWS free tier. And for anything that operates outside of that is not a major concern either, because all of these labs will finish up with teardown instructions to remove all of those resources that you've created. So you'll only be using those resources for a very short amount of time. Once you've created that account, you can then go into the AWS Management Console. So we click on My Account, and then we go to AWS Management Console. Now, before we go any further, you need to make sure that you have downloaded the lab notes that come with this course. So you can see here, it's the Introduction to AWS Lab Notes. The section of the lab notes that we need to have a look at is the controlling costs with AWS. Now, to get these lab notes, if you're looking at this course on Udemy, you will see that in the video, you will see that there are resources there, and we have reference material. If you're interested, you can have a look at the AWS documentation. We have review questions, and we also have here our lab notes for this introduction to AWS. And that will cover not only this particular lab, but also the intro to storage services, database services, computer networking, and a lot of other labs that we're going to be doing. Or if you're looking at this course from Backspace Academy, you'll again see this Materials tab, which will have the same information in there as well. So I'll just close out of those two. Okay, so here we are in the AWS Management Console. If we want to find a service, we can just type it in. For example, if we're looking for the S3 or Simple Storage Service, there we can find it, S3. And that's quite a good way of doing things. The other way of finding services, which is what I don't recommend, is you can click on this Services tab here, and you can see all of the services, and they're grouped according to a category, being compute and developer tools. The problem with this is that these categories change quite regularly, and it can be quite difficult to find what you need. And I think the easiest way is just to type it in the search box here, and you'll get exactly what you need. So we're going to have a look at the billing. So we can click on billing, and we can go through to here to the billing console. So we'll click on that. And there's our billing console. We could also get there by clicking on our account details up here. So we click on our account, we get our drop-down details, and we can click on our billing dashboard. And that should take us to the same thing. And so there we go, not a problem. Okay, so there's our dashboard, and it will show our spend summary. And as you can see here, we've got nothing because I haven't really done anything with it this month. But as you go along, you may get something there, but again, most of it will be covered under the 12-month free tier. If we want to get more information, what we can do is that we can have a look at the Cost Explorer. So we'll just click on that next to Spend Summary. And there we can see we've got our current month's costs and our forecast costs as well. Again, I've got nothing in here. So if we want to get a little bit more information, we can have a look at some reports. So we'll just click on the left-hand side here and click on Reports. And we can select a report, or we could even create our own report. What I'm going to do now is have a look at our monthly costs by service for the last 6 calendar months. And that's a pretty good one. Let's have a look at that. I'll click on that. And that opens that up again in the Cost Explorer. And here we can see we've got a little bit more detail. So this account is over 12 months old. So it's getting billed for stuff that we're using here. So I can see here in July, it got billed 50 cents for Route 53 and 23 cents for EC2 services. We can see here we've got a big spike here for registrar. So what that one is that I purchased a domain name for one of these labs, and that cost me $11. So just be aware, if you are going to be purchasing a domain name, that will be a fixed cost that you will be paying, and it will not be covered under the free tier. But I will make you aware of that if there is a lab that requires you purchasing a domain name. Okay, so that's one thing to have a look at. It's quite good, but it's also great to be able to be a bit more proactive and identify costs or overrun of costs before they actually occur. And that's where the AWS budgets can come in. So let's go into budget. So we can just click on the left-hand side here, budgets. And we can get to the AWS budget service. So I'm just going to get rid of that pop-up there. Okay, so there we have it. Other way we can do it is we can just go into the search, type in budget, and there we have AWS budgets. And that should take us to the same place. And so there we are. Okay, let's create a budget. It's going to be a cost budget. Click on next. Okay, we need to set the budget amount for the month. Let's have a look at that first. Set the budget amount. It's going to be every month, and it's going to be a recurring budget. We're going to do this on a regular basis. It's going to start straight away. It will be fixed. And our budget amount, let's make it $10. Let's type in 10. We'll just ignore budget scoping. You don't need to be concerned about that. It's a little bit advanced. And we don't need to be concerned about the advanced options there as well. We'll give our budget a name. I'm just going to call it backspace spend. That'll be fine. You can call it whatever you want. And we'll click on next. Now, what we can do is that we can create a budget alert. So if we're looking like we're going to exceed our monthly budget, we can get an email sent to us automatically to make sure that we're aware of that. Okay, so our budget amount is $10. Let's add an alert threshold. And we're going to do 80% of our budgeted amount. We could also do an absolute value so that we could put in here $8, and it would do the same thing because our budget amount is 10, and so 80% of that is going to be $8. And our trigger is going to be actual, but we could also do forecasted costs. So that's quite good as well. So if we're forecasting that we're going to exceed our budget, we could also do that. I'm going to leave it with actual. And we can have some notification preferences. So let's put in an email address. And we can also have an SNS alert or a simple notification service alert or a chatbot alert. We won't be too concerned about those. We'll leave those. They're a little bit more advanced for us. We'll learn more about that sort of stuff as we get later on into the course. We'll click on next. So there we go. Now we can also attach an action. Now an action is quite an advanced thing, but for example, just say you're working in a large organization and an individual user exceeded their budget or a department exceeded its budget. What you can do is that you can implement an action that will automatically restrict that person or that department's permissions to create more resources. And so that's quite a good one if you're working with a large organization and you don't want those costs to just blow out completely. Okay, we're not going to do that. It's a little bit more advanced for us right now. We're just going to leave it as an email alert and we'll click on next. Okay, there we go. We've got our budget type. The name of it is backspace spend. It's a monthly budget amount of $10. We've got an alert when it exceeds 80% of that budgeted amount. and we don't have any actual actions attached to either. Let's create that budget. Okay, so your budget has been created successfully. So if we do find that we've exceeded that spend, we'll get an email to inform us that we're reaching our budget. Now, there are instructions in the lab notes on how to tear this down and get rid of it. I would suggest you do not do that. Do not follow those instructions unless you're going to create another one again. Leave your account with a budget and with a budget alert. It's a very good thing to make sure that you keep control of any costs and you're aware of any issues that may overrun your costs. So that brings us to the end of this lab on the introduction to the billing and management console and the AWS management console in general. I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we're going to run through some of the storage services that are available on AWS. Then we'll look at some examples of how you can use these. And finally, we'll finish up with a hands-on lab using one of these services. Amazon Simple Service, or S3 for short. It's designed to store and access any type of data over the internet. It's a serverless service, and as such, we don't need to worry about what is behind it. It's obviously a file server, an operating system, a hard drive, but we don't need to be concerned about that at all. We just simply need to create this thing called a bucket, and then we upload objects to that bucket. The bucket grows as we add objects to it, and the size of that bucket is theoretically unlimited. AWS, it just looks after everything for us. Amazon Glacier is the cheapest storage option on AWS, and it's used for long-term archiving of data. It's a serverless service, just like Amazon S3, but it is not as readily accessible as S3, so it should only be used for content that is to be archived. You can also set up a life cycle rule that will automatically migrate old data in Amazon S3 automatically over to Glacier for long-term archiving. Amazon Elastic Block Store, or EBS for short, is a highly available low-latency block device storage, and it's specifically for attaching to servers that are launched with the Amazon EC2 service. It's similar to attaching a hard drive to your computer at home. It works in the same manner. It's block device storage. Amazon Elastic File System, or EFS for short, is network attached storage. Because it is network attached storage, this allows multiple servers to access the one data source in a similar way to a NAS on your network at home can be accessed by multiple computers on that home network of yours. The AWS Storage Gateway enables hybrid storage between on-premise environments and the AWS cloud. It provides low latency performance by caching frequently used data on premises while storing the less frequent data in Amazon Cloud Storage Services. A Snowball device is a portable, petabyte-scale data storage device that can be used to migrate large amounts of data from on-premise environments over to the AWS cloud. You simply download your data to the Snowball device. You then send it off by courier to AWS. They will receive that and then upload that data to an AWS storage service for you. Okay, so let's have a look at some examples of using the storage services. In the white there, we've got the AWS cloud. Now we can create a VPC inside that AWS cloud, and that VPC, or virtual private cloud, is our own private space within the AWS cloud. And that is an impenetrable fortress against attack. and no one will be able to enter our own private space without us allowing that to happen. Now let's just say we launch 2 servers in our VPC. Now we want these servers to have access to data and somewhere to store that data. And so in a normal environment, you would just add a hard drive to that server. So in the same way, we can attach an Amazon Elastic Block Storage device to our servers. So that's great. We've now got high-speed access to our data. But what if we want that data to be available to both of those servers? So here we've got 2 EBS volumes. What if we want that data to be on only one volume? So as we know from our computer at home, we can't attach a hard drive or a block device hard drive to multiple computers. It just doesn't work like that. So in a situation like that, in your home network at home, you could just go out and purchase a NAS or Network Attached Storage device. You would attach it to your network. You would set up your operating system in your desktop computers to have a mount target for that network attached storage. So when you go to your G drive or E drive or F drive or whatever that may be, it will point to that network attached storage. In the same way that we can do that with our home network, we can also do the same thing with AWS. Elastic File System is network attached storage. So with EFS and a mount target for each individual instance, we can enable multiple servers to access the one data source. Now, what if we don't want to worry about mount targets, block devices, and all this sort of stuff? We just want somewhere where we can upload objects to in a similar way that we do with Google Drive or something like that. And we also want to have an automated solution that over time migrates that data over to something more low cost and more long-term for archiving. Now, that is where Amazon S3 comes in. We can use Amazon S3 to create a bucket, store objects in that bucket, delete objects, do whatever we want with it. We can also set up a life cycle rule on that bucket so that over a period of time, as objects age, they can be migrated over to an Amazon Glacier vault. And that will be for long-term archiving. It will still be accessible. It just won't be as readily accessible as the S3 bucket. But the advantage is that we'll be using the lowest cost storage that is available on AWS. Now that S3 bucket will be located in the AWS cloud. It's not located in our VPC. Now remember, we said the VPC is our own private space within the AWS cloud, and nothing gets through it without us allowing it to come through. So that is where a VPC endpoint comes in. We can create one of those, and that will allow traffic to flow in and out of our VPC, specifically for that S3 service. So let's have a look at a hybrid storage example where we've got on-site storage in a corporate data center, and we also want to have that stored in the AWS cloud on Amazon S3. Why would we do that? Well, it's great for a disaster recovery solution because we can still have high-speed access to our data in our corporate data center, and at the same time, we're taking advantage of the durability and availability of Amazon S3 as a disaster recovery solution in the event that our on-site server goes down. So the first problem that we're going to encounter is that this corporate data center may have petabytes of data, and to transfer that via the internet to the AWS cloud is not going to be practical. It's just too much and it's going to take too long. To solve this problem, AWS can send out to us a Snowball device. And that is a high-capacity device that can store petabytes of data. We can upload our data to that Snowball device, and then we can send that back to AWS, and they will upload that for us into that Amazon S3 bucket. Then we've got to find a solution for making sure that the data in our corporate data center is synced with the S3 bucket. Now that's where the AWS Storage Gateway comes in, and that will orchestrate all of that syncing for us. And so if you've got a high-speed link between your corporate data center and the AWS cloud, which is what you can have with the AWS Direct Connect service, you can have the Storage Gateway orchestrate and manage all of that syncing for you. It will get your popular content, your content that is frequently accessed, and it will store copies of that on-site in your on-site storage. But at the same time, it will also store all of that data in the Amazon S3 bucket for you. Then you've got the advantage of having all of the durability and availability of Amazon S3 as a disaster recovery solution. But at the same time, you've got high-speed access to your data, which is also stored on the corporate data center. Let's have a go at using the Amazon S3 service. What we're going to do now is that we're going to use the AWS Management Console to connect into the AWS cloud. Then we're going to create an Amazon S3 bucket. We're going to upload some files to that bucket. Then we're going to download those files from that bucket. And then finally, we're going to empty the bucket and delete that bucket. The instructions for this lab are detailed in the Intro to AWS lab notes that you used for the previous lab. Let's get into it. Welcome back to Backspace Academy. Before we start this lab, you need to make sure that you've got a copy of the Introduction to AWS lab notes. You should already have downloaded this for the last lab. And the section that we're going to be working on is the creating an S3 bucket and uploading files. From the AWS Management Console, we'll search for Amazon S3. Okay, so we've got into Amazon S3. Now your screen will look a little bit different to this because you haven't created a bucket previously. I have, and I've got some buckets here listed. So what we'll do now is we'll create a bucket. So we'll click on Create Bucket. Now the bucket name must be unique across the entire AWS cloud. So for example, if I type in here Microsoft, and if I try and create a bucket called Microsoft, I'll just scroll down and click on Create Bucket. It will reject that because a bucket with the same name already exists. That's no surprise to us. So let's have a look at putting in something more unique. Okay, that's pretty unique. P. Cody, and then my name, and then backspace-intro-lab. I'm pretty sure that doesn't exist. The region, always use US East, North Virginia, because that is the largest region in AWS and supports all of the available AWS services. If you use a smaller region, it may not support all of those services. So you may run into trouble when you're doing some of these labs. So always make sure that you use the US East, North Virginia region, and that is what our lab notes are based upon. We're going to keep this as a private bucket and block all public access. If we wanted, we could enable bucket versioning on this bucket. What that means is that if we have documents and we want to keep control of the versions of those, we could upload those and we could revert back to different versions of those documents. Very handy. It's also very handy for software development as well. So if you've got a website and you're uploading it to S3, and you can actually use S3 to host a website. You can keep track of the versioning through Amazon S3, and you can always revert back to a previous version of those documents. We can also add a tag if we wanted to. So if we wanted to keep track of costs by an individual tag, we could have a tag attached to this bucket, and we could view costs by that tag as well in our billing console. We could enable default encryption if we'd like. I'm going to leave this disabled. We're not going to worry about encrypting this. We're just going to create a bucket and then delete it afterwards. We'll leave the advanced settings as they are. This is just a simple lab. Let's keep it simple and create this bucket. So it obviously has accepted that unique name, and it has successfully created that bucket. I'm just going to close that pop-up there. If we scroll down, we can see that we've got our bucket that has been created. We're going to click on that bucket and have a look at it. So as we can see here, it is an empty bucket, has no objects inside of this bucket. What we can do now is that we can upload some files. So we'll click on upload. And the easiest way I find to upload objects is simply to drag and drop, especially if you've got multiple files or an entire folder. Simply drag and drop that from your file explorer onto the screen here, which is what I'm going to do now. So I've got a folder called audio, and it contains some MP3 files. So I'm just going to drag and drop that entire folder onto the screen. And there we can see we've got a folder, and it was called audio, and it contains these files, which are MP3 files. That looks fine. What we can do now is we can upload that. We could also change the permissions on this if we'd like to. We're going to keep it private by default, and we'll click on upload. So depending on how many files and how large these files are, it will upload quite quickly, or if there's a lot of them, it may take it a bit longer. Okay, so after a bit of time, it has uploaded those files, and we can see there that these files have been uploaded, and they've been put into a folder called audio, and everything has been successful there. So I'm just going to close out of this screen, this success screen. And there we can see we're back into our bucket description there, or our bucket details. And we can see now we've got this folder called audio, which I dragged and dropped and uploaded. We'll click on that and see what it has. And there we can see we've got our MP3 files have been uploaded. Let's have a look at downloading one of these. So I'm just going to click on the smallest one, this one here. What we can do now is click on the download button and download that. So there we can see it has successfully downloaded that back. Now, one thing I want to show you is that we've got this object URL here. I'm going to open that up in a new tab, and let's see what happens. So access is denied. We cannot access that through that URL. The reason being is this is a private bucket, and we have tried to access that file directly from our browser, not through Amazon S3, and it's not allowed. So if we go back in here, the only way that we can download that, because it is a private bucket, is that we can click on this download link here. This object URL link will not download the file for you. So that brings us to the end of the lab. Very quick and simple lab just to introduce you to using one of these storage services. What we're going to do now is tear this all down and make sure that, it doesn't hang around and give us a bill. Although on the free tier, that won't be giving you a bill anyway. What we'll do is go back to the S3 console. So just clicking up here, we can click on S3. Should be able to get it through here as well. So we can hear, if you just open up this hamburger icon, you can see here we can go back to buckets, or we can click up here. So I'm just going to click on buckets and close that back out again. We'll select that bucket. So this time I'm going to simply select it. I'm not going to click on the bucket. I'm just going to select it. And then I'm going to empty that bucket. So going to empty all of the objects in that bucket. Now, because we're going to be permanently deleting those, we need to type in to permanently delete. So we've successfully emptied that bucket, and there's nothing that has come up in failed to delete. So there's no failed object deletions. That's pretty cool. We'll exit out of this. And now we're going to delete the actual bucket itself. We needed to empty the bucket out first because you cannot delete a bucket that has objects. You can only delete an empty bucket. So again, we select that bucket. We don't click on the link, just select it. And we'll click on delete. Now we need to put in the name of the bucket in order to delete it. And we'll click on delete bucket. And we've successfully deleted that bucket. So that brings us to the end of a very simple introduction to the Amazon S3 service. I hope you enjoyed it, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll have a look at the different options that are available for running databases on AWS. We'll then have a look at a database example, and finally, we'll finish up with a hands-on lab where we'll be creating a database server on AWS and then remotely connecting in to that database. The Relational Database Service, or RDS for short, is a fully managed database service that makes it easy to launch database servers in the AWS cloud and scale them when required. The RDS service can launch servers for MySQL, including variations of the MySQL database engine with MariaDB and Amazon's own enterprise version of MySQL, Amazon Aurora. Standard PostgreSQL is also available, and also available as Amazon's Enterprise Aurora PostgreSQL. Microsoft SQL Server and Oracle are also available. Amazon DynamoDB is AWS's NoSQL database as a service. It's a serverless service like Amazon S3, and as such, you don't need to worry about the underlying infrastructure behind it. AWS takes care of everything for you, and it provides high speed, extremely low latency performance. Amazon Redshift is a fast, fully managed, petabyte scale data warehouse that is based upon the PostgreSQL database engine. If you're looking for a big data storage solution, Redshift is perfect for this. Amazon Elasticache is an in-memory data store or cache in the cloud. It allows you to retrieve information from fast, fully managed in-memory caches instead of relying for slower disk-based databases. The AWS Database Migration Service orchestrates the migration of databases over to AWS easily and securely. It can also migrate data from one database engine type to another totally different database engine type. For example, you can use it to migrate from Oracle over to Amazon Aurora. Amazon Neptune is a fast, reliable, fully managed graph database service. It has a purpose-built, high-performance graph database engine optimized for storing billions of relationships and querying the graph with millisecond latency. Now let's have a look at how you might use some of these database services in a real-life example. On the right there, we've got our corporate data center. And inside of our corporate data center, we've got an on-site Oracle database. Now let's just say that Oracle database, it's old, it's worn out, it's outgrown its capacity, and it needs to be replaced. Now you've done a total cost of ownership analysis on the situation, and you've identified that it is far more cost effective to host that database on the AWS cloud. So the first thing that you are going to want to do is to launch an RDS database instance. Now let's say you want to further reduce your costs by not having to pay for the Oracle licensing fee. And what you can do is that you can launch an Amazon Aurora database instance, and that will be running either the MySQL or the PostgreSQL open source database engines. And by doing that, you're not going to be paying for a licensing fee. The disadvantage of that is that some of the fields of data that are located in that Oracle database may not be compatible with the Amazon Aurora MySQL or PostgreSQL fields. And what you are going to need to do is that when you take that data out of your Oracle database, you're going to have to change it and manipulate it to suit the Amazon Aurora database. And that is where the AWS Database Migration Service comes in. You can define a database migration workflow by specifying the source database, the target database, and any operations on that data that need to occur during that migration of that data. Once you've done that, you can then run the database migration job. And that will look after everything for you. It will migrate that data from that on-site Oracle database to your Amazon Aurora database, and at the same time, it will be giving you feedback through the AWS Management Console as a dashboard on the performance of how that job is actually going. Because that job could take hours, it could take days, it could take weeks, depending on how big your Oracle database is and how fast your connection to the AWS cloud is. And it will also give you feedback of any errors and alert you to any problems that may occur. Once our RDS instance is up and running and the data has been migrated over, then we can look at launching a web server that can receive traffic and requests from the outside world over the internet, and then get that data that is required from the RDS database and then return that back to the requester. Now, let's just say we're getting a lot of requests from the outside world, and a lot of that is for the same data. What we can look at doing is getting all of our regularly accessed content and putting it into an Elasticache node. And because the Elasticache node is serving those requests from its memory, not from a solid state drive, as is the case with the RDS service, it will be returning that very quickly and it will be at a lower cost. Now, we need to take into consideration that the costs of storing data in memory is more expensive than storing that data on a solid state drive. And so we need to make sure that that Elasticache node only contains regularly accessed data. So the way that we would do that is that requests would come in from the outside world to the web server. The web server could then check to see whether that data is in the Elasticache node. If it is in the Elasticache node, it will simply grab that data and then forward it back to that requester. Let's just say a request comes in and that data is not in the Elasticache node. So then the web server will go to the RDS database instance. It will get that data if it's there. And after it has got that data, it will then write that data into the Elasticache node. And at the same time, it will define a time to live, or a TTL, for that specific data. And once that TTL has expired, if there are no further requests for that data within that TTL, then that data will be removed automatically by the Elasticache service from the Elasticache node. And by doing that, all of that data that's in the Elasticache node will be regularly accessed data that has been accessed within that time to live period. Now, let's just say a request comes into that web server for either writing to or deleting from that RDS database. So the way that would work is that the request would come into the web server. The web server would then either delete or write to the RDS database. If it is deleting from the database, then it would also delete from the Elasticache node as well. If it's writing to the database, then it would also write to the Elasticache node, and again, it would define a time to live period, so that if that data is not requested within that time to live period, then it will automatically be removed from the Elasticache node by the Elasticache service. Okay, let's have a go at doing this ourselves. In this lab, we're going to be launching an RDS database instance that will be using the MySQL database engine. That will be covered under the AWS free tier, so this lab's not going to cost us anything. Now, because we're launching that within our VPC, which is our own private space within the AWS network, no access will be allowed to that RDS instance unless we allow that to happen. So that RDS instance will have a default security group associated to it. And that security group is a firewall to the outside world. And it will have rules that will prevent access to that database instance. So to allow access to that RDS database instance, we are going to need to create a new security group. And within that security group, we are going to define a rule that will allow access from our remote computer. Then when we are launching our RDS instance, we simply define and associate that security group with that instance, and that database will be launched with that security group associated to it. Once we've done that, we can then install the MySQL Workbench software on our remote computer. And then provided we've got the username and password that we created for that database, we will be able to connect into that database instance and manipulate that database. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got your introduction to AWS lab notes on hand. And the section that we're going to be working on is creating a SQL database with RDS. So starting off in the management console, the first thing that we need to do before we create our RDS instance is that we need to make sure that we create a security group that will allow remote connection into that RDS instance, because by default, it will be private and that will not be allowed. So we're going to create a security group, and we're going to have a rule in that security group that is going to allow access from the wider internet, and someone who accesses it will need to have the username and password for that database to access. So what we'll do now is we'll search for the VPC service, and there it is. And we need to go into security groups. So we'll scroll down and go to security groups, and we're going to create a security group. We need to give the security group a name and a description. That will be fine for a description. We need to make sure that we're selecting our default VPC. So I'm just going to close this, make sure that we're selecting our default VPC here. There we go. Now we need to create some inbound rules that are going to allow inbound traffic to this database. Let's add a rule, and the traffic type is going to be for MySQL. So scroll down, and here we can see MySQL and also Amazon Aurora. We'll be receiving traffic on port 3306, and the source will be anywhere IPv4. And we're going to add another one. And again, it will be MySQL Aurora. And we're going to do this for IPv6. Now, if we wanted to really secure this down, we could actually, instead of having anywhere, we could actually use my IP. And that would lock it to your IP address. You can do that, that's fine, and that will make it a little bit more secure, so only you can access it using your IP address. I'm not going to do that because I have multiple internet connections coming in through a load balancer here, and so my IP address changes quite a bit, so I have to use this anywhere. But you can use that my IP if you want to lock it down specifically to your IP address. Now the outbound rules, we don't have to define an outbound rule because security groups are stateful. And what that means is that any inbound requests that come in to this database, the outbound responses will be automatically allowed. We could add a tag to this if we wanted. We're not going to bother with adding a tag to that. And we just click on Create a Security Group. So there we can see it's created our security group. It's got those two inbound rules, which are going to allow MySQL access on IPv4 and IPv6 on port range 3306. Okay, so now what we need to do is to create this RDS instance and then associate this security group with that RDS instance. So we'll go and search here for RDS. And I'm just going to open that up in another tab. So let's go ahead and create the database. Now it's going to be a standard create that we're doing. It's going to be a MySQL. Scroll down and it's going to be Community Edition of MySQL. That's fine. And we're going to use the free tier. We don't want to pay for this, so we're going to use that. We'll give this database a name and we're just going to call it, well, I'm going to call it backspace intro AWS. And our credentials, we'll leave that as admin. We'll just put in a password and we'll confirm that password. So the instant class is going to be a T2 micro, and that is because that is covered under the free tier. So you can see that that's the only option that is available for us because that's the only one on the free tier. We'll leave that storage as it is. We're not going to worry about storage auto scaling. And we don't do multi-availability deployment. So if this was not on the free tier, we could set up multi-AZ deployment where we'd have multiple instances in multiple availability zones. So if one of the availability zones goes down, the other availability zone will kick in. And so again, connectivity, we're going to be using our default VPC and we're going to allow public access. So we click on yes for that. And we're just going to keep that with the default subnet group. We'll scroll down and we need to select our existing VPC security group. There it is, backspace RDS intro lab. There we go. And we can see there it's put that in there ready to go. We're not going to have any preference for an availability zone. We'll go down to authentication. We're going to stay with password authentication. And we're just going to expand additional configuration here. So we're going to have an initial database. So we'll give it an initial database name and we'll just call this test. And we're not going to worry about automated backups. This is only a lab. We're not going to be doing anything spectacular with it. We're just going to create a database and then tear it down afterwards. So we don't need to have automated backups. We don't need enhanced monitoring or anything like that. Okay, so no preference for maintenance window. We'll leave deletion protection unchecked. We don't need to worry about that. Okay, so estimated monthly cost. The Amazon RDS free tier is available for you up to 12 months. And there we go. So we're underneath that, so we're not going to be getting a bill. So let's create that database. So after a certain amount of time, it does take quite a bit of time to launch and set up this database, but it will eventually happen. Okay, so after quite a bit of time, quite a few minutes, we've got this database has been created. Now, if we click on this refresh button here, we'll be able to see that its status is now available. Okay, so let's just click on that now. I'll just close this green pop-up. Okay, so what we've got here is an endpoint and port. So that is the URL that we're going to use to connect into this instance remotely. And of course, we're going to do it on port 3306 as we defined in that security group rule. So in order to connect remotely, we need to have the MySQL workbench installed on our remote computer, and we can install that on Windows, Linux or Mac, not a problem. The instructions there, or the link to connecting to it, is in the lab notes. So I'm just going to click on that now. And that will give you the instructions on how to install the MySQL workbench. And so there will be an installer there. So we'd go to the Windows installer there. Or if we're looking for a different one, we can look at Ubuntu here, or sorry, Linux here. So we can click on Workbench for Linux or Workbench on Mac OS. So just follow those instructions, and depending on what client you're using, Windows, Linux or Mac, just install the right software on there. So once you've done that, you can open up the MySQL workbench, and I'll just get that into the screen here. There we go. Okay, so I've already got a connection here, which I'm just going to delete. So what we need to do now is to create a connection to our RDS instance. The way we do that is we click here on the plus sign. And what we need is a connection name, and it can be anything that we want. I'm just going to call it RDS. The connection method is going to be standard TCP IP. Now the host name, we need to get that, and it's going to be on port 3306. So we're going to jump back into the RDS console, and we're going to get that endpoint, and we're going to copy that, and we're going to put that in here. And the username is not root, it's going to be admin, because that was what we used for our username when we created the RDS instance. We used admin, and you need to remember what that password was. And let's go and test this connection. Okay, it's asking for a password. We'll put that password in and see what happens. Okay, so we successfully made the MySQL connection. Now, if that didn't work for you, just go into the lab notes. There is a section there on troubleshooting your connection issues. Most probably you haven't selected the database when you've created as public access, or you haven't done the security group properly and associated that to the instance, or you used the wrong username and password. So the username we created was admin, and the password was whatever you created when you launched that instance. So that is fine. So I'm going to click on OK. Now, to have a look inside that, I can just double click on this, and it's going to open the SQL editor. Okay, and there we have our MySQL workbench with its editor, and we can do all of our SQL statements and that sort of thing that you would do. We can see here we've also got this test database, which was created for us by AWS. Okay, that brings us to the end of the lab. We've created an RDS instance, and we've connected into it remotely using the MySQL workbench. Everything seems to work fine. Again, if you have any troubles, just go back to the lab notes, look at the troubleshooting section, and it's pretty straightforward. You should be able to work that out. So I'm just going to close out of the workbench, and I'm going to go into the RDS Management Console, click on our databases here, select our backspace intro AWS database. I'm going to go to Actions, and I'm going to delete this database. We delete. Now we don't need to create a final snapshot because there's nothing on this database, so we'll just get rid of it. And we acknowledge that it's not going to be available after this, that's fine. And then we also need to type in here, delete me. Okay, and we'll delete that. Okay, so after quite some time, We have now successfully deleted that instance. Now, because we've deleted it, we can now delete the security group. We can't delete the security group until this instance has been deleted. So let's jump into the VPC Management Console again. And here's our security group. We're just going to go into Actions, Delete Security Group. And yes, we're going to delete that. And it was successfully deleted. So that brings us to the end of this lab. I hope you enjoyed it, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll have a look at the compute and networking services of AWS. We'll then have a look at some examples, and finally, we'll finish up with a hands-on lab where we're going to deploy a WordPress web server using the Amazon EC2 service. Amazon Elastic Compute Cloud, or EC2 for short, provides virtual servers in the AWS cloud. You can launch one or thousands of instances simultaneously and only pay for what you use. There's a broad range of instance types with varying compute and memory capabilities, and those will be optimized for different use cases. Amazon EC2 auto-scaling allows you to dynamically scale your Amazon EC2 capacity up or down automatically according to conditions that you define. It can scale up or down by launching or terminating instances based on demand. It can also perform health checks on those instances and replace them when they become unhealthy. Amazon Lightsail, it's the easiest way to launch virtual servers running applications in the AWS cloud. AWS will provision everything you need, including DNS management and storage, to get you up and running as quickly as possible. Amazon Elastic Container Service, or ECS for short, is a highly scalable, high-performance container management service for Docker containers. The containers, they will run on a managed cluster of EC2 instances. AWS Lambda is a serverless service and lets you run code in the AWS cloud without having to worry about provisioning or managing that service. You just upload your code and AWS takes care of everything for you. So let's have a look at how we could use these services to deploy a web server in the AWS cloud. Here we have the AWS cloud and our virtual private cloud, or VPC, located inside that. And remember, a VPC is our own private space within the AWS cloud, and no one can enter that unless we allow them to enter it. We can launch an EC2 instance, and that can be running our web application, for example, WordPress. So what happens if this single EC2 instance becomes overwhelmed by demand? For example, we might have released a new product and our WordPress application cannot deliver the web pages quickly enough to satisfy that. What we could do is that we could tear down that instance and put in a bigger instance that could handle that demand. And that is called vertical scaling. And that used to be all the rage 10, 20 years ago. But the problem is that it takes time to do that. And while we're doing that, our application is not running. And also, what happens when the demand goes back down again? Do we have to tear that down and then put in a smaller instance? And what happens if that happens every day? What happens if that happens every hour? It's just not going to be economical for us to do that. What we can do is that we can horizontally scale, and we do that by adding more instances. And as demand goes up, we add more instances. And as demand goes down, we terminate those instances. And that way, we still have continuity of our application. Our application will always be running because there's always going to be at least one EC2 instance to look after the demand. One problem with this architecture is that it has multiple endpoints for our web server. And that's not practical because Customers are not going to go to one endpoint until that stops working and then go to another one and then another one. It's just not going to work like that. And obviously their bookmarks in their browser are not going to be valid. So we need a way of having one single endpoint for that web application that our customer can go to, and then having a way of distributing those requests to a EC2 instance that is available. That is where elastic load balancing comes in. So it can receive traffic from our end users, and it will distribute that traffic to an EC2 instance that is available. So a request will come in, it will distribute it to an available EC2 instance. Another request will come in and it will distribute it to a different EC2 instance that is available. And it will balance the load across those EC2 instances. And if one of those EC2 instances become unhealthy, it will fail a health check with the elastic load balancer. And then the elastic load balancer will no longer send traffic to that unhealthy EC2 instance. But what happens if that demand is only for a short period of time, for example, half an hour? What do we do then? It's not going to be practical for us to terminate instances when demand goes down and then launch instances manually when that occurs. We can't do that every hour. It's not going to be practical. And that's where the auto scaling service comes in. It can launch EC2 instances automatically when the demand on those instances increases, and it can terminate automatically EC2 instances when the demand on those instances goes down. It can also perform health checks on those instances, and if one of those instances becomes unhealthy for whatever reason, it can replace that instance with a healthy instance, and it will do that automatically without you having to do anything at all. So now we'll have a look at the networking and content delivery services. Amazon CloudFront is a global content delivery network, or CDN for short, that securely delivers your frequently requested content to over 100 edge locations across the globe. And by doing this, it achieves low latency and high transfer speeds for your end users. It also provides protection against DDoS attacks. Amazon Virtual Private Cloud, or VPC for short, lets you provision a logically isolated section of the AWS cloud. And you can launch AWS resources in that virtual network that you yourself define. And this is your own personal private space within the AWS cloud, and no one can enter it unless you allow them to enter it. AWS Direct Connect is a high-speed, dedicated network connection to AWS. Enterprises can use it to establish a private connection to the AWS cloud in situations where a standard internet connection won't be adequate. AWS Elastic Load Balancing, or ELB for short, automatically distributes incoming traffic for your application across multiple EC2 instances and also in multiple availability zones. So if one availability zone goes down, the traffic will still go to the other availability zone, and your application will continue to deliver responses to requests. It also allows you to achieve high availability and fault tolerance by distributing traffic evenly amongst those instances, and it can also bypass unhealthy instances. Amazon Route 53 is a highly available and scalable domain name system, or DNS for short, and it can handle direct traffic for your domain name and direct that traffic to your back-end web server. Amazon API Gateway is a fully managed service that makes it easy for developers to create and deploy secure application programming interfaces, or APIs, at any scale. It handles all of the tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. It's a serverless service, and as such, you don't need to worry about the underlying infrastructure. AWS looks after everything for you. So let's have a look at an example of how we can use these networking services of AWS. So here we've got the architecture that we looked at before in the compute section, but one thing we didn't mention was availability zones. So let's just say that we've launched that architecture in a single availability zone. What happens if that availability zone goes down? What happens to our traffic? Our traffic has nowhere to go, and our application stops delivering responses to requests. That is why it's always desirable to have our architecture distributed across multiple availability zones. That way, if one availability zone goes down, the other one will continue to operate, and the infrastructure within that other availability zone will continue to respond to requests. We can launch EC2 instances in multiple availability zones, and our elastic load balancing service can distribute that traffic across multiple availability zones as well. So if one availability zone goes down, the elastic load balancer will continue to distribute traffic to the availability zone that is still healthy, and to those instances in that availability zone that are still healthy as well. So let's just say our application running on these EC2 instances is a WordPress web server, and that contains lots of images and lots of video that is static content. It's not really changing that much, and it's not efficient for us to continue to keep delivering that from our EC2 instances. We would like somewhere to put that where it can be delivered with high speed and low latency, and to take the load off our EC2 instances. That is where the CloudFront Content Delivery Network, or CDN, comes in. So we can get these large images and large videos that are not really changing that often, and we can put that in a CloudFront distribution, and CloudFront will cache that and distribute that across hundreds of edge locations across the globe. So when your end user requests that video or those images, it will be delivered to them with really high speed and low latency. And at the same time, it's going to take the load off your EC2 instances and is going to significantly reduce your costs. At the same time, dynamic content that is changing regularly, CloudFront can forward those requests over to the elastic load balancer, which will then forward them to an EC2 instance. So that way you have the best of both worlds. You have dynamic content delivered as a dynamic content, and at the same time you have these large videos and images that aren't really changing that often delivered very rapidly. Now that CloudFront service, or that CloudFront distribution, will have its own DNS name that we can put into a browser, and we can directly access that. The problem with that is that that DNS name for that CloudFront distribution will be something very complicated and just won't mean anything to our end user at all. So we would prefer to have our end user type in a domain name and have the requests for that domain name forwarded to that CloudFront service. As you can see here, we've got example.com, and that is where Route 53 domain name service can come in. So Route 53 will grab those requests for your domain, example.com, and it will forward those requests over to the CloudFront service, and the CloudFront service will handle it from then on. So let's just say we work for a large enterprise that has its own corporate data center. And the reason it's got its own corporate data center is because that is located where the employees work. And we don't want our employees to be slowed down by a network. We want them to be able to work efficiently. But at the same time, we have resources on the AWS cloud that those employees also need to access. So we need some way of having a high-speed connection between our corporate data center and the AWS cloud. And that is where the AWS Direct Connect service comes in. And that can provide a very high-speed fiber optic network between our corporate data center and the AWS cloud. And that is completely private. Okay, so that's a very complicated architecture, and don't be too concerned if that's very overwhelming, because if you're going on to become a cloud practitioner, you're not going to need to really be able to produce this yourself. As an associate level certification, that is a different story. You'd be expected to create this yourself. But cloud practitioner, you'll need to know what these services do. You'll need to know that Route 53 will forward requests for your domain name to a back-end endpoint. CloudFront will distribute your content to hundreds of edge locations across the globe. Elastic Load Balancer will receive requests and distribute those requests to multiple instances across multiple availability zones. A virtual private cloud is your private space within the AWS cloud. The AWS Direct Connect is a high-speed fiber optic network connection between an on-premises corporate data center and the AWS cloud. If you understand that, then you're well on your way to passing the cloud practitioner exam. Okay, so coming up next, we're going to have a lab. So make sure that you download the Introduction to AWS lab notes that come with this course. So what we're going to do is that we're going to launch an EC2 instance, and we're going to select an Amazon machine image of a WordPress web server. And that will allow us to deploy a WordPress server on the AWS cloud. And then we're going to be able to go to our browser and view our website that was created by that EC2 instance. And we're going to do that all through the AWS Management Console on our desktop computer. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got a copy of the Introduction to AWS lab notes, and you should already have that from the previous labs. The chapter that we're going through is creating a web server with EC2. From the AWS Management Console, we need to search for EC2. And there we have that. Okay. So now we're in the EC2 Management Console. We're going to launch an EC2 instance now, and that will be a Linux instance. We just click on Launch Instance here. We could also go to the Instances menu here and do that same thing, but we're just going to do it from here. Just click on the red Launch Instance. Now what we're going to do is that we are going to launch a Linux server, but that Linux server is also going to be running the WordPress application. What we need to do is that we need to find an Amazon machine image that has both the Linux application and or the Linux operating system and the WordPress application. The way that we do that is that we go to the AWS Marketplace. Now the AWS Marketplace is a marketplace for these machine images, and lots of vendors, including AWS, and we can see here we've got Trend Micro, Juniper and Barracuda. They all supply machine images to do different things. So we're going to search and see if there is a Bitnami WordPress AMI. Bitnami is a great company that has been producing lots of different AMIs that are free, and they also provide great support for those as well. So they're a great company and they produce really good quality AMI. So I'm going to use that one, and I'm going to click on enter and see if I can find a WordPress AMI created by Bitnami. So there we can see WordPress certified by Bitnami and Automatic. Automatic are the developers of WordPress. So this is a pretty good AMI to use. We'll just use the standard one here. You don't have to worry about the multi-site one. We'll click on select. Now, when we select this Amazon machine image, the first thing that comes up will be this list of costs. Now, don't be too concerned about this. The software, that's free. It's open source and free software. We're not going to get billed for that. The WordPress application is free, and so is Linux. But you can see here we've got costs of 1.2 cents per hour. Now, you will not be incurring that cost if your account is less than 12 months old, because this will be covered under the AWS free tier. Let's scroll down and we'll click on continue. Now we need to choose an instance type. And of course, we're going to choose the one that is going to be free tier eligible. So on the free tier, we are allowed to launch a T2 micro instance and not get billed for it. We'll click on next, configure instance details. Now here we can see we have our default VPC has been selected. Now remember, the VPC is our own private space within the AWS cloud. When we create an AWS account for the first time, this default VPC is created for us, and it has a lot of things already done to set that up to allow a web server to operate and receive traffic from the wider internet. If you have created other VPCs, and you can do that yourself, you can of course create multiple VPCs, and many of them up to the limit of your account. But here we're going to use the default VPC that has been created by AWS, because that is set up ready to go for us. The other thing that we need to make sure that we do is we need to make sure that we've got a public IP address assigned to this web server. If we don't do that, then this web server will not be discoverable on the internet. So we need to make sure that that is enabled. So by default here, it is enabled for us. So I'm just going to select enable just to be sure. We'll click on now, add storage. We'll leave the storage as it is. That is going to be fine for us. We'll click on add tags. Now we can add tags to this that can allow us to track these resources if we need to. I'm going to put a name tag onto this. Now when we select name, we need to make sure that the name tag has a capital N in front of it. If we use a lowercase n, the tag will still be created, but it won't come up as a name for our instance. So make sure that you do capital N here. The value, I'm just going to call it Backspace Academy WordPress. That's fine as a name. Next, we need to configure our security group. Now, a security group is like a firewall that we can associate with an EC2 instance. Now, that is additional to any firewall rules that you may put in your Linux operating system. So it is possible to have multiple layers of firewall. So what we're going to do here is that we're going to create a new security group, and we need to make sure that that security group allows inbound access to our web server from the wider internet. Now, normally the standard is for when you create a security group that it will be basically blocking all access to it, and you need to add these rules. Now, the Bitnami AMI has automatically set this up for us. So it's allowed for secure shell access on port 22. What that means is that if we have AWS credentials, we can access the Linux operating system of this EC2 server. We're not going to need to do that, but we'll leave that as it is. The other thing that we need to do is that we need to have HTTP and HTTP access for the wider internet. So people need to be able to view our web server, of course. So that comes in on port 80 and 443, and that's going to be for anywhere to come in. So by doing that, we just click on review and launch, and that security group will be automatically associated with this EC2 instance, and it will allow traffic from the wider internet to view our website. We'll click on review and launch. So we can see here we're going to get our WordPress AMI is going to be installed. The instance type will be a T2 micro. And here we can see our security group is going to have access, very important, on HTTP. and HTTPS, which is SSL. Now, we won't be connecting in using HTTPS or SSL. The reason being is that to have that set up, you need to create an SSL certificate and associate that with your instance. So we're not going to do that. It's a little bit advanced for us at this stage. Our tag, we can see here we've got our name tag. So everything looks fine. We'll click on launch. It's going to ask for a key pair. Now, we would need that key pair if we were going to be connecting into this instance via secure shell and accessing the Linux operating system of that server. Now, we're not going to need to do that. We're just going to be doing everything through the WordPress application. So we don't need to create a key pair. So I just need to click on this. I acknowledge that that you won't have access to the direct operating system. Let's click on Launch Instances. Now, this will take quite some time, quite a few minutes. So go away, get yourself a cup of coffee and come back, and the launch status will change and you will be able to have a look at your EC2 instance. So here we can see the instances are now launching. We'll just scroll down and view those instances. So although they're launching, now I've got an old one here that I've terminated. So this is the one we're interested in, and it's still pending. So go away. Oh, it's now running. Now, although it's running, it's not necessarily having the WordPress application up and running as yet. And so it'll need to go through some additional checks there. So I'm just going to have a look at the status checks first. And we can see here it is running, the system is running, and the instance is running. That looks fine. We're going to see whether we can actually access our WordPress application. So what we'll do now is we'll click on the instance ID. And here we can see we've got a public IP address. So remember when we launched this, we set enable a public IP address so that we can actually access this web server or the wider internet and people can have a look at our web server. We've also got this domain name here. So either of those we can access. I'm going to click on that and see what happens. So the site can't be reached. What that means is that we need to give it a bit more time, probably about 5 minutes or so for it to go through all of its checks and make sure that this application is up and running. So go away, have that cup of coffee and then come back and we should be in business. Okay, so after quite a few minutes, I've just kept refreshing this browser screen here. Now I've got a different screen. It says your connection is not private. The reason for that is that we're trying to connect into this web server using SSL, and it's not allowing us because we don't have an SSL certificate associated with this web server. So what we're going to do is that we're just going to connect in without SSL, and the way that we do that is we just get that domain name that we opened up. Just going to copy that, paste that into here, and that will open up with HTTP, not HTTPS. There we go. We've got our WordPress application up and running. Everything looks good. So our users can access our WordPress blog or whatever it is that we've got here. But at this point in time, we can't access it as administrator. So if we go into WP admin, so we just go /, so WP-admin, and that will take us into the login screen to our WordPress application. So we need this in order to create blog posts and all that sort of thing. So if we don't have that, we're not going to be able to do anything with our WordPress blog. So we need to get that. And the good people at Bitnami, what they have done is that they have outputted through the Linux console the username and password for us. So if we go into the logs, the system logs for our Linux operating system, we will be able to find that. The way that we do that is that we go into Actions, then we go into Monitor and Troubleshoot. And then we go to Get System Log. And that will get all of the outputs from our Linux operating system console. There's a lot here, so we're just going to scroll down that. And here we can see setting the Bitnami application password, and the default application username is user. So we can just go in here, we'll copy this. We'll go back into this login screen here. Our username was user. And we're just going to paste in that password. And that should get us in. There we go. We've logged in as the administrator of our WordPress application. From here, we can go into posts and add a new post. There we go. We can add a new post. We can do whatever we want. Let's have a look at that. So that's all working pretty good. So we can add a new post. We can change the theme, do whatever we want with that WordPress application. So that brings us to the end of this lab. You've learned a lot. You've learned about how to launch a server, associate a security group to that server, how to go into the system logs of that server. Pretty advanced stuff. Now, if you get stuck, make sure that you go back to the lab notes because there is a section on troubleshooting. So I'll just get that up here now. So there we can see we've got our troubleshooting viewing your WordPress application. So if you don't get this screen up here, you can just scroll down here to the troubleshooting section. And that'll go through all of the things that may have gone wrong with your security group or whatever it may be. So I'm just going to get out of that. What we need to do now is we need to clean this all up so that we're not going to get a bill at all. But if we created a second EC2 instance, then we would be getting billed for a second or for that second EC2 instance. So we need to make sure that we clean this all up. So just close out of that. I'm going to scroll back up to this EC2 instance. I'll click on the instance ID here to get into it or to get the instance summary of that. To terminate this instance, we need to go to instance state. Now we have options to stop it or terminate it. We're going to terminate it because we don't need it anymore and just get rid of it and we'll never get billed for that. Click on terminate instance and we just click on terminate. And we've successfully terminated that instance. Okay, so I hope you enjoyed this lab. Pretty advanced one. And again, if you have any troubles, just go to those troubleshooting section of the lab notes. And I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll have a look at the different management and governance services on AWS. We'll then finish up with a hands-on lab. In that lab, we will use the CloudTrail service to record user activity in our account. CloudFormation allows you to use a text file to define your infrastructure and to use this text file to deploy resources on the AWS cloud. This allows for defining of your infrastructure as code, and you can manage your infrastructure with the same version control tools that you can use to manage your code. The AWS Service Catalog allows enterprises to catalog resources that can be deployed on the AWS cloud. This allows an enterprise to achieve common governance and compliance for its IT resources by clearly defining what is allowed to be deployed on the AWS cloud. AWS CloudWatch is a monitoring service for AWS cloud resources and applications that are deployed on the AWS cloud. It can be used for triggering scaling operations, or it can also be used for providing insight into your deployed resources. AWS Systems Manager provides a unified user interface that allows you to view operational data from multiple AWS services and to automate tasks across those AWS resources. that helps to shorten the time to detect and resolve any operational problems. AWS CloudTrail monitors and logs AWS account activity, including actions taken through the AWS Management Console, the AWS Software Development Kits, the command line tools, and other AWS services. So this greatly simplifies security and analysis of the activity of users of your account. AWS Config enables you to assess, audit, and evaluate the configurations of your AWS resources. This greatly simplifies compliance auditing, security analysis, change management and control, and also operational troubleshooting. AWS OpsWorks provides managed instances of Chef and Puppet. Chef and Puppet can be used to configure and automate the deployment of AWS resources. AWS Trusted Advisor is an online expert system that can analyze your AWS account and the resources inside it. And then it can advise you on how to best achieve high security and best performance from those resources. Okay, let's have a go at using one of these management services. CloudTrail is without a doubt one of the most important services of AWS. It provides monitoring and logging of all of the API calls that are made, not only from outside of your account from the wider internet, but also those made from within your own account. This is extremely important because attacks coming from within your account will not be picked up on your external firewalls. For example, you may have a malicious employee who is doing damage to your infrastructure, and CloudTrail can monitor and pick this up well before it becomes a major problem, and could also initiate automatic corrective action, such as restricting the user's access. In the lab, we will create a trail, and then we will access the Amazon S3 service. We'll create a bucket, delete the bucket, do a few things. After we've done that, we'll have a look at the CloudTrail and we'll see the activity. Okay, let's go to the lab. Welcome back to Backspace Academy. In this lab, we'll create a CloudTrail trail, and then we'll have a look at what gets stored in one of those. Now, make sure that you've got the Introduction to AWS lab notes that come with this course. And the section that we're looking at is monitoring user activity with AWS CloudTrail. So start off, let's go to the CloudTrail Management Console. And we'll create a trail. We'll give that a name. And create trail. That's all we need to do to create a CloudTrail trail. So that's been created, and it's also created an S3 bucket to store a log of all the events that are being recorded by CloudTrail. So let's go to the S3 console. And I'm just going to open that up in another tab. And if we scroll down here, we'll be able to see there is our CloudTrail logs bucket that is recording everything we do. So let's just create another bucket just to give it something more to record. We'll give that bucket a name. Make it unique, I guess. There we go. And create bucket. So we've created that bucket. Let's delete that bucket. And delete bucket. Now let's just go into our CloudTrail logs bucket and see what was recorded in there. So we'll just click on that now. And we can see here we've got a folder here for all the AWS CloudTrail logs. We'll just click on that, scroll through those, keep going. And there's our CloudTrail, US East 1, because we're in US East 1. And keep going. Okay, so here's some here. So we could probably open up the latest one, which would be this one up the top. So I'm just going to click on that. Sorry, I won't click on it, I'll select it. And then click download. So we've just downloaded that. I'm just going to open that up in a text editor and have a look at it. So here we can see in Notepad, it's a JSON format file. Not very readable because it's not really designed to be read by people. It's more designed to be read by software. So what we can do is that we can copy all this and put it into a JSON editor, which can allow us to have a look and see what is actually going on there. So I'm just going to go to jasoneditoronline.org. It's a free website that allows you to view these JSON editors in a more viewable format. So I'm just going to copy everything there and paste it into the left-hand side. And there we go. And I'm just going to copy here. So click the button to copy the contents over from the left pane to the right pane. And they're exactly the same. So what we need to do now is on this right pane, we just need to click on tree to switch to the tree mode. And there we can see we've got a tree of all of these records. And there's 244 of those records. So let's have a look at one of those. And we can see here that the event source was Amazon S3 and it got the bucket policy status. We've also got here the user identity, so who actually did that. And we can see here username, P. Cody. So everything that I have done and anything that anyone else has done on this account is recorded in this CloudTrail log. And again, this is great because it can be, and it is designed to be, consumed by software that can actually respond to that. So you could write an application that could consume this data and could respond to that data if there is something that could alert it to that. So it's a very powerful thing from a security perspective, but also if you have a breach and you know about what time it was, you can go through these CloudTrail logs and have a look and see who the user is, or the IAM user that is responsible for that occurred. So that brings us to the end of the lab. What we'll do is clean it all up now. The first thing we'll need to do is to delete the CloudTrail trail to stop it from recording into that S3 bucket. So we just click on the CloudTrail and just click delete and delete. That's quite simple. Let's go into the S3 management console. Now that there's no logs getting recorded to that bucket, we can now empty the bucket and then delete it. So we'll just go into the S3 console and we'll click on empty for that CloudTrail logs bucket. And we just need to permanently delete. We'll empty that. So that's emptied that. And now that we've emptied it, we can just exit out of here and we can delete it. So we'll just scroll down again. There it is. We'll click on delete. Just copy the name. Paste that in there and delete the bucket. There we go. That brings us to the end of the lab. I hope you enjoyed it and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll have a look at the application integration and customer engagement services. We'll then have a look at some examples, and finally we'll finish up with a hands-on lab where we're going to use the SES service to send an email. AWS Step Functions makes it easy to coordinate the components of distributed applications and microservices using a visual workflow. For example, you may want a second function to always follow the first and only run if and when the first function succeeds. And you may want to execute two functions in parallel. For example, you can define your application visually as a series of steps. You then define the process flow of those steps, and then you can deploy your application automatically. Amazon Simple Workflow works in a similar way to step functions in coordinating multiple components of a business process. For new applications, it is recommended to use step functions, not the SWF service. Amazon Simple Notification Service, or SNS for short, is a flexible, fully managed pub/sub messaging service. What that means is that you can create a topic and users can subscribe to that topic. And when you publish a message to that topic, the users that have subscribed to that topic will receive that message. It can also be used for push notifications to mobile devices. Amazon Simple Queue Service, or SQS for short, is a fully managed message queuing service. And that makes it easy to decouple your applications from demand. What that means is that it allows messages to build up in a queue until the processing server that processes those messages can catch up with demand. So let's have a look at an example of using these services to decouple our application from its demand. So let's just say we have an application and it's running on an auto-scaling group of 2 instances, and that application is a process server. It's not a web server, it's processing messages as they come in, and those messages could have information on an image that needs to be processed, or a video that needs to be processed, or a cryptography problem that needs to be solved. Those messages come in, and as that demand increases, or the number of messages coming in increases, then the auto-scaling group will also add more instances to cope with that increasing demand. So what happens if that increase in demand occurs over a 1-second period and it's a very large spike in demand? Our auto-scaling group cannot handle that sort of scenario because it's going to take at least 5 or 10 minutes for each instance to launch and be up and running. So what happens in the meantime is a problem for us. In a similar way that a bank has a queue, when people come into the bank and the teller is too busy to serve them, customers can build up in a queue until such point in time that the teller can reach them. We can do the same thing with the SQS, or Simple Queue Service. We can let those messages come in and they can build up in a queue until such time that our auto-scaling group of EC2 instances can get to that queue and empty out the queue. And that's great because we have now decoupled the demand from our application. And so if spikes come in, our application can handle it. But what happens when the average demand exceeds what the maximum capacity of our auto-scaling group of EC2 instances is? So I'll give you an example. Say we've got our bank and all of a sudden we had 5 tellers and 4 of those tellers have become sick. They've got influenza or whatever. But the same amount of people are coming through the door and the queue is going to build up and the queue will never decrease. It will continue to increase in size indefinitely. The same thing can happen in this architecture. For example, we might have a whole heap of unhealthy instances and all of a sudden our capacity cannot meet the average demand. And so the SQS queue is going to grow indefinitely. Or we may have done an update to our application that is faulty, and that SQS queue is also going to continue to increase because the messages are not getting processed. What we can do is that we can set up a CloudWatch metric, and that will alert us with an SNS email notification that our SQS queue is continuing to grow and that we need to investigate that further. Of course, it is much better to implement an automated solution as well. Now, normally, we would use a CloudWatch metric on the instances to signal that those instances are overloaded and we need to increase our capacity of our auto-scaling group. Now, in this situation, that's probably not going to happen because these messages are just going to build up in the queue. And so we need a way of notifying the auto-scaling service that the queue is increasing. The way we can do that is again with a CloudWatch metric that will alert the auto-scaling group that the SQS queue is too big and to put on more instances to reduce the size of the queue. And at the same time, when the queue is empty, CloudWatch can send a metric to the auto-scaling group to reduce the number of instances and terminate those so that we're not going to be wasting those resources. Let's have a look at some customer engagement services. Amazon Connect is a self-service contact center in the cloud, and that is delivered on a pay-as-you-go pricing model. It has a drag and drop graphical user interface, and that allows you to create process flows that define customer interactions without having any coding at all. Amazon Pinpoint allows you to send email, SMS, and mobile push messages for targeted marketing campaigns, as well as direct messages to your individual customers. For example, for an order confirmation. Amazon Simple Email Service, or SES for short, is a cloud-based bulk email sending service. Coming up next, we're going to be doing a lab using the Simple Email Service to send an email. So make sure that you have the introduction to AWS lab notes on hand, and I'll see you in the lab. Welcome back to Backspace Academy. In this lab, we're going to be introducing you to the Simple Email Service. Before we start, make sure that you've got a copy of the Introduction to AWS Lab Notes. The section that we're going through is the Sending Emails with Amazon SES. Okay, here we are in the Amazon SES Management Console. Again, we get there by searching simply SES, and there we have Amazon Simple Email Service. The first thing that we need to do is that we need to create an identity with SES. The way that we do that is that we supply our email address to the SES service. It will send us a verification email with a verification link. We will click on that link, and by doing that, Amazon SES has verified our ownership of that email address. The way we do that is that we click on Create Identity here, or we can go to Verified Identities here on the left and click on Create Identity there as well. Now we want to verify ownership of an email address. So you must have access to its inbox to open the verification email. I'll just paste in my email address. And all we need to do is click on Create Identity. Okay, so that email has been sent and our status is currently unverified. So what I need to do is I need to go and refresh my inbox and see if it's come in. So there it is, it's come in straight away. What I'll need to do is click on the verification link in that email. And there we go. Congratulations, you have successfully verified an email address. So now we can start using that email address as the sender of emails with Amazon SES. So we go to verified identities now, and we'll click on our identity there. And what we can do is we can send a test email. We're just going to use formatted there. It's going to copy my email address, and the scenario will be a custom one, and the recipient will be just myself. I'm just going to send myself an email from Amazon SES. The subject will be test, and we don't have to worry about putting in the body there, and send a test email. So I'm just going to check my email inbox now and see whether that came through. And it has come through successfully. So we've successfully created an identity, and we've used that to send an email. Now, obviously, we want to send more than one email. We'd like to set this up with our server account or something like that, and to send emails out through our web page or whatever it may be. So what we need to do is that we need to get our account to have production access. So as we can see here, this Amazon SES account is in the sandbox mode. To unlock it and to unlock the sending limits and restrictions and to get those off, we need to request production access. So here we go, we can request production access, and that will allow us to send quite a lot of emails for marketing or transactional, as we can see here. So we just fill out the details there. It's pretty self-explanatory, and what we're going to be using it for. We need to agree to the AWS terms and conditions, and of course the acceptable use policy. If we abuse this service, then obviously we won't be able to have access to it again. So we can just click on submit request. Once we've filled out those details, Amazon will get back to us, and hopefully they will approve that request for you. So that brings us to the end of the lab. You can go back and delete that identity if you want, but you may want to leave it there because it doesn't, you don't get billed for it. So you might want to use it to send some emails out later on. But that brings us to the end of the lab right now, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we're going to be running through some of the analytics and machine learning services on AWS. Amazon Elastic MapReduce, or EMR for short, is AWS's Hadoop framework as a service. You can also run other frameworks in Amazon EMR that integrate with Hadoop, such as Apache Spark, Hive, HBase, Presto, and Flink. Data can be analysed by EMR in several data stores, including Amazon S3 and Amazon DynamoDB. Amazon Athena allows you to analyse data stored in an Amazon S3 bucket using your standard SQL statements. Amazon FinSpace is a petabyte-scale data management and analytics service purpose-built for the financial services industry. FinSpace also includes a library of over 100 financial analysis functions. Amazon Kinesis allows you to collect, process, and analyze real-time streaming data. Amazon QuickSight is a business intelligence reporting tool similar to Tableau, or if you're a Java programmer, similar to BERT, and it is fully managed by AWS. Amazon Cloud Search is a fully managed search engine service that supports up to 34 languages. It allows you to create search solutions for your website or application. Amazon OpenSearch is a fully managed service for Elastic.co's Elasticsearch framework. This allows high-speed crawling and analysis of data that is stored on AWS. Amazon OpenSearch, it was formerly called Amazon Elasticsearch. So let's have a look at some of the machine learning services on AWS. AWS Deep Lens is a deep learning enabled video camera. It has a deep learning software development kit that allows you to create advanced vision system applications. Amazon SageMaker is AWS's flagship machine learning product. It allows you to build and train your own machine learning models and then deploy them to the AWS cloud and use them as a back end for your applications. Amazon Rekognition provides deep learning based analysis of video and images. Amazon Lex allows you to build conversational chatbots. These can be used in many applications such as first-line support for customers. Amazon Polly provides natural sounding text-to-speech. Amazon Comprehend can use deep learning to analyze text for insights and relationships. This can be used for customer analysis or for advanced searching of documents. Amazon Translate can use machine learning to accurately translate text to a number of different languages. Amazon Transcribe is an automatic speech recognition service that can analyze audio files that are stored in Amazon S3 and then return the transcribed text. Okay, so let's have a look at using one of these machine learning services, Amazon Rekognition, for analyzing some image and video. Welcome back to Backspace Academy. In this video, we're just going to be introducing you to Amazon Rekognition, and we're just going to jump into the Rekognition console here. And of course, we just type in REK because AWS can't spell. Amazon Rekognition, there it is. And it takes us to here. Now, Amazon Rekognition is something that me personally blows me away. And the reason it does is because back in my early days, well over 30 years ago, I used to be a young engineer working in the industrial robotics space. And I remember going to an automation conference, and there was one of the presenters there who had a robot that was integrated with a vision system. And that vision system could recognize a triangle, a circle, a square, and these objects would come down a conveyor, and the robot would recognize, or the vision system would recognize that, and then the robot, its end effector, or its hand, its end effector would rotate in line with that object, and depending on what it was, it would pick that object up and it would plonk it into a bucket. And for me back then, that was the most incredible, groundbreaking thing that we had back then, and it was huge. And now I look at what we've got now with image recognition, and it's incredible. The amount of technology that has come out in the last 5 years is beyond belief. But at the same time, it's very scary because the amount of information that we're receiving, and with the CCTV that is commonplace everywhere, it does pose privacy issues. So that is a concern for me, but the technology itself absolutely blows me away. So here I am again. I'm getting a bit off track here, but here is Amazon Rekognition, the console. What we're going to do is have a look at the demo. So we just click on Try Demo here. And all the demos here on the left here. So we've got label detection, image moderation, facial analysis, and all of these in here. So let's have a look at label detection. So here is an image that has been uploaded to the Amazon Rekognition service, and it's identified some labels in that image. So it's identified that there's a car there with 98.8% probability or certainty that that car is there. Automobile, the same. Vehicle, the same. Transportation. There's a person, there's a human, we can have a look at some more. Skateboard. And so that's pretty good. Let's have a look at another one. So here's another image, totally different. And here we can see it's identified that it's a city. It's a metropolis, high-rise buildings there. It's identified the water. So that's pretty good. So you wanted to recognize things within an image for whatever reason. That's quite handy. So let's have a look at another one that's a little bit more powerful. So let's have a look at image moderation. Now this one's quite good. So I just click on view content. So the content is blurred. So what this is doing is that it's analyzing this image and it's identifying whether it has any offensive content in it. So here it's analysed that image, and it's come back with the result that there's no moderation labels detected. It's just simply a family on the beach having a picnic. But let's go to the next image. So again, we'll click on view content. So this one, okay, it's come up with suggestive, 81%, female swimwear or underwear, revealing clothes. Now, I don't find that image at all offensive, but if you're in a country where this may be seen as offensive, that exposing your body in that way or exposing your face or hair or whatever, then you may want to blur that out on your website. So you may want to have geographic checking of where your website is ending up and making sure that that is actually blurred. So this is a very good service as well. Let's have a look at another one. So facial analysis. So here we can see it's picked up that it looks like a face, 99.9% certainty on that. It's a female face, 21 to 33 years of age, pretty good. Smiling, wearing glasses. So a lot of information there has been picked up on this simple photograph. Let's have a look at the next one here. So it's picked up here. We've got the first person here is the man. Appears to be male, 99.4%. Very good. 22 to 34 years of age. And not wearing glasses. Very good. Let's have a look at the next one. So the lady there appears to be female, 99.8%. 22 to 34 years of age. Again, very good. And the young girl there. Again, female, 5 to 15 years of age. So that's pretty powerful stuff, and it's done a really good job of analysing those images, I think. And let's have a look at another one. So we've got celebrity recognition. So within the service for Amazon recognition, it has a get celebrity. So you can upload an image and it can identify whether that is a celebrity on their list of celebrities. So here we can see Jeff Bezos from Amazon and Andy Jassy there from Amazon. So you'd expect them AWS to pick those up pretty good. I'm going to give them one a little bit more difficult. So I'm just going to upload one here and drop that on there. So here we go. We've got an image of Nicole Kidman and Keith Urban. Now, this image I chose specifically because Keith Urban is not looking into the camera. He's got his side profile there. So, but when we look at it here, with 97% confidence, it has picked up Keith Urban, and 97.9% it's picked up Nicole Kidman. That's very good. I think that's incredible, actually, that it would actually pick up from a side profile like that is really good. So let's have a look at face comparison. So if we have different faces of the same person, then it should pick that up. So here we've got this girl here and another picture of her there, and we can see similarities. And let's have a look at another one there. So is this girl in those pictures? And we can see again, 99.9% she is. Let's have a look at another image here. So is she in those? Yes, she is. Is the other girl in those? And the other girl is in there as well. So that's quite good. Very powerful stuff. If you want to find people, very good for police services, I think, if they want to find if they're looking for a criminal and they've got a photo of that criminal, they can go through CCTV imaging or something like that and find that person. Very powerful stuff. The next one, text in image. Pretty straightforward. It picks up text there on an image and quite accurate there. Very good application here. It's picking up the number plates on a car. Again, great for police or whatever, or for security services. Not so good for privacy either, but that's another discussion that needs to be had at the government level, I think. Here's another one which I think is very good and has been used quite a bit, I think, is checking whether personal protective equipment is being worn by someone. So if someone comes into a building, the system can recognise if they are wearing the appropriate PPE. So you can see here that obviously face coverage now with COVID-19 is very important. And we can see here we've selected face cover, and it comes in here, persons with required equipment, and it comes up with 0. Now that doesn't mean that it hasn't found anyone with the appropriate PPE on. What it means, it's found person 0. So this will be an array of whatever it finds. So it finds more than one person there, it will have 0 and then a comma and then 1. So persons with required equipment is 0. So, and persons without, so if it's without, it'll just be empty. And same with intermediate if it's can't really tell. And we can check for hand cover. So are they wearing gloves? And the person's wearing gloves. Are they wearing head protection? And there they are. Let's try this next one here. And so this shows exactly persons without required equipment. So they're not wearing gloves. That's why this has come up here. So I've selected gloves or hand cover. If I deselect hand cover, they should be all okay. So there we go. The persons with required equipment, that's okay. So, and here we can see we've got 0, 1, 2, and 3. So we've got person 0, person 1, person 2, and person 3. So that's where that 0 came from. And there's no one there that doesn't have the required PPE. So we can scroll through these people as well here. So we'll scroll from that one to each one there, and we can see each one that's picked up. You can also analyze video. So let's have a look at that. So here's a video of our friends from Amazon. And you can play that video. And what it's picked up is it picked up that we have a human there. We've got a person. There's an audience, a crowd. The person's giving a speech. There's some furniture. One of them has a beard and a chair. There's no moderated labels there. It's picked up celebrities as well and people. So that's a pretty quick overview of Amazon Rekognition. I thoroughly recommend you go to the Amazon Rekognition console and have a play around with it yourself. If you're a developer, this is really pretty powerful stuff. So there is an API, and there also is modules within the software development kits for JavaScript, for Java, PHP, all the different languages, Python. So you can actually import the Amazon Rekognition software development kit into your application, and then you can start using this yourself by just sending a payload of an image or a video, and the Rekognition service will send that back to you. So it's really good. You can create some really powerful applications using this sort of stuff, especially anything around machine learning is really quite powerful. So that brings us to the end of the demonstration on Amazon Rekognition. I hope you got a lot out of it, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. In this lecture, we'll have a look at the security, identity, and compliance services of AWS. Now, this is a very important category of AWS, and as such, there is a very broad selection of products that are available. Once we've done that, we'll finish up with a hands-on lab using the Identity and Access Management service. AWS Artifact is an online portal that provides access to AWS security and compliance documentation. and that documentation can be readily available when needed for auditing and compliance purposes. AWS Certificate Manager issues SSL certificates for HTTPS communication with your website. It integrates with AWS services such as Route 53 and CloudFront. And the certificates that are provisioned through AWS Certificate Manager are completely free. Amazon Cloud Directory is a cloud-based directory service that can have hierarchies of data in multiple dimensions, unlike conventional LDAP-based directory services that can only have a single hierarchy. AWS Directory Service is a fully managed Microsoft Active Directory service in the AWS cloud. AWS Cloud HSM is a dedicated hardware security module in the AWS cloud. This allows you to achieve corporate and regulatory compliance while at the same time greatly reducing your costs over using your own HSM in your own infrastructure. Amazon Cognito provides sign-in and sign-up capability for your web and mobile applications. You can also integrate that sign-up process with external OAuth providers such as Google and Facebook, and also SAML2 providers as well. AWS Identity and Access Management, or IAM for short, allows you to manage user access to your AWS services and resources in your account. Users and groups of users have individual permissions that allow or deny access to your resources. AWS Organizations provides policy-based management for multiple AWS accounts. This is great for large organizations that have multiple accounts and they want to manage those and the users that use those accounts centrally. Amazon Inspector is an automated security assessment service. It can help to identify vulnerabilities or areas of improvement within your AWS account. AWS Key Management Service, or KMS for short, makes it easy to create and control encryption keys for your encrypted data, and it also uses hardware security modules to secure your keys. It's integrated well with AWS services such as Amazon S3, Redshift, and EBS. AWS Shield provides protection against distributed denial of service, or DDoS for short, protection against DDoS attacks. The standard version of AWS Shield is implemented automatically on all AWS accounts. Web Application Firewall, or WAF for short, is a web application firewall that sits in front of your website to provide additional protection against common attacks such as SQL injection and cross-site scripting. It has different sets of rules that can be used for different applications. Coming up next, we'll have a lab on the Identity and Access Management, or IAM service. So I look forward to seeing you in the lab. Welcome back to Backspace Academy. Before we start the lab, make sure that you've got the introduction to AWS lab notes, and the section that we're going to be working on is creating an IAM user. Now, up until now, we've been logging into our account using the email address and password that we used to create that account. And that is logging in as a root user, and it is not desirable to do that. The reason I say that is that the root user will have access to everything, access to finances, credit card, access to locking people out of that account. And so that is something that cannot be compromised. Otherwise, you're in a lot of trouble. So what we do is that we lock that down. We put a very long password and complicated password on that account. And we can also have multi-factor authentication if we want to go to that next step of locking that down. Once we've locked down our root access, we can create an IAM user, and we can log in as that IAM user And that IAM user will have permissions specific for what we need to do. And so if we, for whatever reason, need root access, we can still get that if we need to. But we log in for the most part as an IAM user, and that protects our account. Okay, first thing we need to do, go to the IAM Management Console. There it is. Now we're going to be creating a user, so we'll go on the left-hand side here and we'll select Users. Now I use this lab just for, or I use this account just for these labs, nothing else, just for recording of labs. Not a lot of users there, just myself and Jason. What I'll do now is add a new user, and we'll give this user a name. Now we have two options here for access type. We have programmatic access and AWS Management Console access. So we've been using Management Console access so far, where we have a username and a password to sign in, so we know all about that. But we could also have programmatic access, which supplies an access key ID and a secret access key. So a key pair there, and you can use those with remote access with a command line interface or through your own applications that use the software development kit. But you never ever put these credentials in your code. If you need to actually get that into your application, then you can have a pop-up form in your application where you can enter it in manually. Otherwise, you use other means of access such as AWS Cognito. So we're not going to worry about programmatic access. We're just going to do Management Console access here, and we'll put in a password, a custom password. Okay, now I've just typed in BuzzBox there, and I use that password for everything. I use it for my banking with my Wells Fargo bank account. I use it for all my government stuff. I use it for everything. I use it for my AWS account. No, I don't. Of course I don't. Make sure you have always a very long password, and even better, use a password generator like I do. But I'm just going to do this for a lab, and I'm just going to type in anything there because I'm going to delete it afterwards. We'll click on Next, Permissions. Okay, here we are in Setting Permissions. So we can add this user to a group. So I've got some groups that I've created before, and I've given those groups permissions. And so if I put a user into that group, that user will inherit the permissions of that group. What I'm going to do now, I'm just going to attach an existing policy. So I'll click on Attach Existing Policy, and these are AWS managed ones, or we have job function ones. So if there's a job, obviously here we've got administrator access. We'll be able to give that person administrator access for an administrator if that's what they need, and we can rest assured that AWS has done that work for us to make sure that they have got those required permissions. But we could also do our own permissions. I think I've got one in here as well. So I've got one here for our Backspace instructors that come on board. So they have their own set of permissions, which is pretty well everything except for IAM. So I'm just going to give this user administrator access and click on Next Tags. Now we could put a tag in here so we could find this. If we've got lots and lots of users and we wanted to break them up into different departments, we could have a key here called department, and then the value would be their department, and we could search users by a tag. We're not going to worry about that. We've just got one user here now. We'll click on Next Review. So there we go. Our username, it's going to have Management Console access with a password. It's a custom password, and they're going to have administrator access. I'm going to click on Create User. So the user has been created, and this is the sign-on link. Now we could also download the credentials for this user if we wanted to. We won't worry about that now, But if we were going to have programmatic access, that's probably something that you would want to download, that key pair, if you wanted to access your account through a command line interface application remotely. But we don't need to do that. So what we can do now is that we can go to this sign-in page now. So this user will have a sign-in page where they can put their details in. So I'm just going to open that up now. And just going to put in the username and put in that password there and sign in. Okay, so we've been asked to put in a new password. So I'm just going to put in a new password now. And we'll confirm that. So that's worked. So I'm now logged in. I'm not going to save that. I'm now logged in. If you look up the top here, I'm logged in as backspace-test. There we go. So what I can do now is just go back into IAM. I'm just going to delete this user. And delete. Okay, so that user will be deleted. So there we go. That user has been deleted. Now, just before we finish up the lab, we've deleted the user, but we're also logged in as that user. So if you go to any other pages, it'll lock you out. So if we go to, say, roles over here, you can see now we have to re-authenticate because these IAM credentials that we're logged in with all of a sudden don't work anymore. So we just need to go out and then log out and then log back in as our original user that we did. So we just go back out and we log back in. And this time we select sign in with our root user email over here. Welcome back to Backspace Academy. In this lecture, we're going to finish up with our overview of AWS by looking at the developer, media, mobile, migration, business productivity, and finally, Internet of Things services. We'll then finish up with a look at one of those services, Amazon Workspaces. AWS Cloud9 is an integrated development environment running in the AWS cloud. It allows you to deploy servers directly to AWS from an integrated development environment. We'll be using Cloud9 extensively if you go on to the Developer Associate pathway with Backspace Academy. AWS CodeStar makes it easy to develop and deploy applications to AWS. It can manage the entire CI/CD pipeline for you. It has a project management dashboard, including an integrated issue tracking capability powered by Atlassian Jira software. AWS X-Ray makes it easy to analyze and debug applications. This provides you with a better insight to the performance of your application and the underlying services that it relies upon. AWS Code Commit is a Git repository, just like GitHub, and it's running in the AWS cloud. AWS Code Pipeline is a continuous integration and continuous delivery service, or CI/CD for short. It can build, test, and then deploy your code every time a code change occurs. AWS Code Build compiles your source code, runs tests, and then produces software packages that are ready to deploy on AWS. AWS Code Deploy is a service that automates software deployments to a variety of compute services, including Amazon We'll be using code pipeline, code build, and code deploy quite a bit if you're going on to do the Developer Associate Pathway with Backspace Academy. We'll be creating a fully integrated CI/CD pipeline that will automatically package Node NPM packages and run tests using Mocha before deploying to an AWS environment. AWS recently acquired a media production services company called Elemental, and as a result, there are some very high quality broadcast media services available on AWS. AWS Elemental Media Convert is a file-based video transcoding service for converting video formats for video on-demand content. Media Package prepares video content for delivery over the internet. It can also protect against piracy through the use of digital rights management. Media Tailor inserts individually targeted advertising into video streams. Viewers receive streaming video with ads that are personalized for them. AWS Elemental Media Live is a broadcast-grade live video processing service for creating video streams for delivery to televisions and internet-connected devices. Elemental Media Store is a storage service in the AWS cloud that is optimized for media. And finally, Amazon Kinesis Video streams video from connected devices through to the AWS cloud for analytics, machine learning, and other processing applications. So let's have a look at the mobile services that are available on AWS. AWS Mobile Hub allows you to easily configure your AWS services for mobile applications in one place. It generates a cloud configuration file which stores information about those configured services. AWS Device Farm is an app testing service for Android, iOS, and web applications. It allows you to test your app against a large collection of physical devices in the AWS cloud. And finally, AWS AppSync is a GraphQL backend for mobile and web applications. If you're a developer and you don't know what GraphQL is, then make sure you go out and find out, because it is absolutely revolutionizing the way we think about data. So let's have a look at the migration services that are available on AWS. AWS Application Discovery Service gathers information about an enterprise's on-premises data centers to help plan migration over to AWS. Data that is collected is retained in an encrypted format in an AWS Application Discovery Service data store. AWS Database Migration Service orchestrates the migration of databases over to the AWS cloud. You can also migrate databases with one database engine type to another totally different database engine type. For example, you can migrate from Oracle over to AWS Aurora. AWS Server Migration Service can automate the migration of thousands of on-premise workloads over to the AWS cloud. This reduces costs and minimizes the downtime for migrations. AWS Snowball is a portable petabyte scale data storage device that can be used to migrate data from on-premise environments over to the AWS cloud. You can download your data to the Snowball device and then send it to AWS, who will then upload that to a storage service for you. So let's have a look at the business productivity and desktop streaming applications. Amazon WorkDocs is a secure, fully managed file collaboration and management service in the AWS cloud. The web client allows you to view and provide feedback for over 35 different file types, including Microsoft Office file types and PDF. Amazon Workmail is a secure, managed business email and calendar service. Amazon Chime is an online meeting service in the AWS cloud. It is great for businesses for online meetings, video conferencing, calls, chat, and to share content both inside and outside of your organization. Amazon Workspaces is a fully managed, secure desktop as a service. It can easily provision streaming, cloud-based Microsoft Windows desktops. Amazon AppStream is a fully managed, secure application streaming service that allows you to stream desktop applications from AWS to an HTML5 compatible web browser. This is great for users who want access to their applications from anywhere. Now, one area that is really progressing rapidly is the Internet of Things on AWS. So let's have a look at some of these services. AWS IoT is a managed cloud platform that lets embedded devices such as microcontrollers and Raspberry Pi to securely interact with cloud applications and other devices. Amazon FreeRTOS is an operating system for microcontrollers, such as the microchip PIC32, that allows small, low-cost, low-power devices to connect to AWS Internet of Things. AWS Greengrass is software that lets you run local AWS Lambda functions and messaging, data caching, sync, and machine learning applications on AWS IoT connected devices. AWS Greengrass extends AWS services to devices so they can act locally on the data they generate while still using cloud-based AWS IoT capabilities. There's some really cool stuff going on game development on AWS. So let's have a look at some of it. Amazon GameLift allows you to deploy, scale, and manage your dedicated game servers in the AWS cloud. Amazon Lumberyard, you can see there we've got some images of some pretty cool stuff. It's a game development environment and cross-platform AAA game engine on the AWS cloud. So that brings us to the end of our introduction to AWS. In the next lecture, we're just going to give you a quick demonstration of AWS Workspaces. So I look forward to seeing you in that. Welcome back to Backspace Academy. In this introduction to Amazon Workspaces, I'll be doing this as a demonstration. I won't be doing it as a lab, and there won't be any lab notes for this. The reason I decided to do that is because unlike EC2 that is billed on an hourly rate, Amazon Workspaces is billed on a fixed cost plus an hourly rate. So if you make a mistake and you select a workspace that's not eligible under the free tier, even though you've only used it for a short amount of time, for say an hour or two, you still incur that fixed cost. So I just don't want anyone to make a mistake and end up with a bill, because that bill could be something like $10 at the end of the month, which is something that you don't want to incur. But by all means, if you want to do it yourself, you can, not a problem, but just make sure that you select those workspaces that are clearly marked as on the free tier. Then you're going to get those for free. Okay, so we go to the Workspaces console. Of course, we just search for it under Workspaces, and there it is there. And this is our introduction screen. And if you've used Workspaces before, you won't get this introduction screen. This is just if you haven't used it before. And so this is what you will see. So what we do now is we'll click on Get Started Now. And we're going to go to the Quick Setup. So that's going to do a lot of this stuff for us. So we just click on Launch. And this is where it's important. Take note. We need to make sure that we select one that is free tier eligible. So we can see here, it's automatically selected a free tier one for us anyway. So we'll use that one, that's fine. Or maybe we can use a standard Windows 10 one. That's free tier eligible as well. We'll use that one. Now we need to add our user in here. So I'm just going to put in my details. I'll just create a username for myself. And my email. Okay, so what I'm doing here is I'm creating a user that is going to go into a directory. So that directory could be a Microsoft AD directory, or it could be a Samba Linux directory. It's not an IAM user. So this is a directory that we manage, or AWS may manage the actual service, but it is our directory of our users. They're not IAM users as such. So we click on Launch. So our workspace is being launched. So what is going to happen is it's going to launch a directory service for us, and that person there, P. Cody, myself, is going to be added as a user to that directory, and any more users we can add to that directory as well. And then I can log in to that directory service, and then I can have access to this workspace. So I'm just going to view the workspaces console now. And once that's up and running, I will receive an email with my login details and how to access this workspace. So I'm just going to go away, have a cup of coffee. I'll come back and hopefully it'll be all done. Okay, so it's been about 20 minutes or so, and I've just been refreshing the screen here regularly, and it's finally come up with available. And my email has arrived. It arrived in my junk email. I don't know why, but for some reason, all of these workspaces emails seem to go into my junk folder. So if you find that, that's probably where it is. So I'm just going to open up the email and click on the link. You need to just set a password in here. Okay, so it needs to be a certain length and it needs to have some special characters. So I finally got it to accept my password. Okay, so update the user. So what we need to do now is download our application, whether we're going to be using this on Windows or on Linux or whatever, or Mac. We can download the application. Once we've done that, we can get into our virtual desktop. Okay, so I've now got the application up and running. I need to go back to that email that I received, and I need to get this registration number or registration code. I'm just going to pop that in there and register. Okay. All right, so I'll put my username and password. Okay, so we're signing in now. It's launching a session. It takes quite a while. Just make this screen a little bit bigger. And there we can see, there is our workspace all ready to go. And so from here we can install applications, we can do whatever we would do with a normal desktop. And if you're in an enterprise environment, then you would no doubt get the required applications that your employees need. And then you would create an image, a workspaces image, and you could use that to launch further workspaces. So that brings us to the end of our demonstration on workspaces. I'm going to clean all this up now, so I'm just going to close out of this. And and close out of that there. Now, when we clean this up, there are two things that we need to get rid of. First, we need to get rid of the workspaces, obviously, so we'll get rid of that first. So we'll just click on here and we'll do Actions. Remove workspaces. So that will take up to 5 minutes. So again, I'm going to go away, have another cup of coffee. I'll come back and it should be done. Okay, it's been about 5 minutes or so and our workspace has been removed, but we still need to remove our directory because our quick start that we went through with workspaces created a directory for us, and we will get billed for that if we don't remove it. So just go to Directories and we'll select this directory and we'll do Actions and we'll deregister. So first we need to deregister it and then delete it. Now we won't be able to deregister or delete it if there's any workspaces still attached to it. So we've got rid of the workspaces, so now we will be able to deregister it. So I'm just going to refresh the screen here. And so now it is not registered. So now we can select it and we'll be able to delete that. Okay, so it looks like there is still something attached as well as the workspaces to this directory. So we need to have a look at that. Just going to go to the directory service console and see what applications are still associated with this directory. Okay, so we go to Application Management. So we can still see here we've got Amazon Workdocs is still associated with this directory. So we'll need to get rid of that. We'll delete the Workdocs site. And I also want to delete the user directory. That will be great. So it's going to take a little bit of time before that status goes to deleted rather than deleting. So I'll give that a little bit of time. Okay, so after quite a long time, it wasn't a very quick process. It took about 10 minutes or so. We've finally got this directory has been deleted. The Workdocs has been deleted as well, and the workspaces has been deleted. So we are back to where we started, and we're not going to get a bill because it was all under the free tier. So I hope you got something out of this, and I look forward to seeing you in the next one. Welcome back to Backspace Academy. Elastic Beanstalk, it's one of AWS's deployment services, and it allows you to deploy your applications to complex architectures on AWS. And it does this without you having to worry about the underlying architecture that is behind that. Elastic Beanstalk, it looks after everything for you, and you just need to worry about writing your code. We'll also talk about how Elastic Beanstalk can create highly available and fault-tolerant architectures and what that actually means. And then finally, we'll look at the different deployment options that are available on Elastic Beanstalk. Elastic Beanstalk, it's been around for quite some time, was first launched in 2011. It allows you to quickly deploy and manage applications on environments, and those environments are launched for you without you having to worry about how it all works. It'll automatically handle capacity provisioning. It'll launch a load balancer for you if you need that. It'll auto scale for you, and it can also implement health monitoring so that if one of these instances that are launched becomes unhealthy, it can replace those automatically for you. If you need to change your code after you've deployed it, it's quite easy to upload new versions of that code. And that can be done through the console or the command line interface. And also complete environments can also be redeployed if need be. Your application that you're deploying could be a Docker container. It could be raw code. It could be Node.js, Java, .NET, PHP, Ruby, Python, or Go. You just supply your code and Elastic Beanstalk will deploy that for you, and it will provision that Node.js or whatever environment for you automatically. Or it could be a service such as Apache, Nginx, Passenger, or IIS. The Elastic Beanstalk process, it starts with us going through an application creation process where we will first off upload a version of our software or our code or whatever it is. And then Elastic Beanstalk will launch an environment, and that will consist of EC2 instances, or it could be a single EC2 instance. It could be a multi-AZ environment, but we define that for Elastic Beanstalk, and it will do that automatically for us. From there, we will have our environment launched and our code will be running on that environment. Now, if we find that we need to deploy a new version of that code, we can deploy that to that existing environment, or we can create a whole new environment. It doesn't really matter. So if we deployed it to our existing environment, then when that environment has gone through that update process and the new version is deployed and running, then the environment will feed back to the application to notify that that new version of your application is actually running. One of the big advantages of Elastic Beanstalk is that it can create a highly available and fault-tolerant architecture without us having to worry about how to actually do that. So what is a highly available and fault-tolerant architecture? So here we've got the AWS cloud, and as we know, it's divided up into regions, and those regions are divided up into availability zones. So if we have our architecture distributed across multiple availability zones, if one of those availability zones goes down, our infrastructure will still continue to operate and serve requests. Now, our virtual private cloud, that will span the entire region. So it will span multiple availability zones. And so what we can do is that we can launch instances into both of those availability zones, and that's going to give us high availability if one of those availability zones goes down. Now, in order for our architecture to respond to spikes in demand or increases in demand because an availability zone goes down, what we can do is we can launch our instances using an auto-scaling group. So if demand on one of those or a group of instances increases, the auto-scaling group will add instances to accommodate that. And vice versa. If the demand goes down, we will reduce our number of EC2 instances. And that allows for elasticity in our design. And finally, to receive requests from the outside world and to distribute those requests to those multiple instances, we're going to need an elastic load balancer to do that. And that will also have the advantage of conducting health checks on our instances so that if communication breaks down between the elastic load balancer and our EC2 instance, then our auto scaling group will automatically add additional instances, and that creates fault tolerance in our architecture. Just the same as you've got a number of options available for architecture that you're deploying to, such as a single EC2 instance or a highly available and fault-tolerant architecture across multiple availability zones, you've also got a number of different deployment options that you can use. So for example, if you've got 20 EC2 instances, and all at once deployment will deploy that across all of those 20 EC2 instances all at once. The downside of that is going to be that while that is occurring, your architecture won't be able to respond to requests. So that's obviously not a good thing. So another option there is to do a rolling deployment, and that will deploy your application to a single batch at a time. So what that means is that if you've got 20 EC2 instances, it can deploy that to, say, 2 at a time. So you're not going to be down by much. You're just going to be down from 20 instances down to 18 instances, but your architecture will still be responding to requests. You can also do a rolling with an additional batch. So what that will do is that if you've got, again, 20 EC2 instances, it will temporarily increase to 22 while you're doing those 2 deployments across those 2 EC2 instances. And that way you're still going to have your capacity at 20, which is what you have designed for. The other option there is an immutable deployment, and that is a bit of a variation of the all-at-once. So it's still doing an all-at-once deployment across your 20 EC2 instances. But while that's going on, it's going to deploy another 20 EC2 instances. So temporarily, you're going to have 40 EC2 instances. So it's going to double up a lot on your capacity. But through that period where your environment is being deployed, or your new version or whatever is being deployed to that environment, you're not going to be suffering any downtime. And finally, we've got blue-green deployments, and they will have two environments that will be running your application under the one Elastic Beanstalk application. And so what that is you'll have a blue environment and a green environment. One of those could be a development environment, and the other one could be your production environment. So when you get to the stage where your development environment is ready to go to be deployed, to deploy that, all you simply need to do is to switch over from one environment to the other environment. And then your old environment will then become your new development environment. And so that is very straightforward with Elastic Beanstalk, because what it does, it will simply allow you to switch the domain names for those two environments automatically for you. And so that makes sure that your changeover doesn't involve any downtime for returning of requests. Later on in the course, we're going to learn a lot more about blue-green deployments and how to deploy those across Elastic Beanstalk. But coming up next, we're going to use Elastic Beanstalk to deploy a highly available and fault-tolerant architecture. So make sure that you download the lab notes for this one, and I'll see you in the lab. Welcome back to Backspace Academy. Before we start the lab, make sure that you have downloaded the Introduction to AWS lab notes. And the chapter that we're going through is creating a highly available architecture with Elastic Beanstalk. And starting off in the Elastic Beanstalk console, of course, we get there by searching for Beanstalk. And there it is there. Now, Elastic Beanstalk, I'll just read the description that we've got here. Is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, PHP, Node.js, Python, Ruby, Go, and Docker on familiar services such as Apache, Nginx, Passenger, and IIS. What it does is it allows us to deploy with single clicks very complex architectures without us having to know or do anything with the back-end stuff that's going on. So we can create, and we will create in this lab, a highly available and fault-tolerant architecture. It will be highly available because it will have an elastic load balancer that will distribute requests coming into it to multiple instances that will be across multiple availability zones. It will be fault tolerant as well because it will implement health checking on all of those instances. And if any of those instances go down, they will be replaced because those instances will be inside of an auto-scaling group. And again, when capacity becomes low and demand increases, it will add instances to that auto-scaling group to accommodate that increase in demand. And when demand goes down, the auto-scaling group will terminate instances. So here we are in the start page. We'll click on Create Application. And we'll give our application a name. Now, I'll just have a quick talk about tags. What tags are simply a key and a value pair that we can associate or attach to our resources. The reason you may want to do that is for a number of reasons, that you can search your resources based on those tags. And in your cost management, you could actually search for a key and value, and you could identify all of the resources and the cost of those resources based upon that. So for example, I could put in here a key of department, and this could be anything. You could call it country or whatever, but I'm just going to call my key department, and I'm going to give a value for that key, and we can have multiple values for that key, and we can associate two different resources. So these resources I'm going to associate with the front-end developers department. So now, after I've launched this Beanstalk environment, all of the resources that have been deployed will have this key associated with them. Now we'll scroll down and we need to select what platform. We're going to select Node.js, and we have the option of selecting the sample application or uploading our own Node.js code. So with this, I'm just going to use the sample application. If we uploaded our own code, it would go into this list of applications. So we would click on the left here on applications, and we would have our application in there. When we deployed a different version of our application, that would come up here as well. And so we can quite easily roll back to previous versions of our application. So for now, I'm just going to use the sample application. Now, before I create this application, I'm going to configure some more options, because by default, it will just launch this into a single instance environment, not a highly available environment. So I'm going to click on Configure More Options. As you can see here, we've got a lot of different options that we can select. We can define what type of instance we're going to have, whether it's a T2 micro or whatever. We don't have a load balancer or anything like that as yet. We can have an email address we can put in for our notifications. So a lot of options here we have available. We're going to keep it simple, and we're going to use something that is pre-made for us. So we're going to select high availability. So if we look here before we do that, we can see that there is no load balancer. So if we go to high availability, all of a sudden we will see that we have a load balancer now in this environment, and we'll also have an auto scaling group as well. So all of a sudden we've gone from a single instance environment, and now we're defining a highly available, because it's going to be load balanced across multiple availability zones, and it's going to be fault tolerant. It's going to have instances launched inside of an auto scaling group. That auto scaling group will have health checks on those instances. When they become unhealthy, they will be replaced. So that's all we need to do to get this up and running. Very easy, and we'll create the app. Now this will take quite a few minutes, probably 5 or 10 minutes. I'm going to go away, have a cup of coffee, and I'll come back and it should be done. Okay, so after about 10 minutes or so, we've got our Elastic Beanstalk environment up and running. Let's have a look at it. So we've got it running, the sample application, and we can see all of the information here. There is no errors there. That's looking pretty good. We have this endpoint here. So if we click on that, and there we can see, there is our Node.js web server that is up and running. Now let's have a look at the back end of what has happened here. So very quick and easy it was to do this. We just simply did a few clicks, but in the background there is a lot going on. What we'll do is we'll have a look at the EC2 console. So I'm just going to open that up in another tab. Okay, so here we can see we've got our Backspace Lab environment, and that is one of the instances inside of our Elastic Beanstalk environment. There we can see that. And we've only got one of those because we only defined a scaling of between 1 and 4, I think, but we can check that. I'll just go back. And if we go into our configuration, and we can see capacity here, and minimum of 1 and a maximum of 4. So that's fine. So we don't have any traffic coming in. There's no demand on that auto scaling group, so it's going to have a minimum. If there is a lot of traffic coming in, then it would add instances up to a maximum of 4. Those instances would be across multiple availability zones as well. So at maximum capacity, we would have 2 instances in 2 availability zones. Now let's have a look at some of the other stuff. So we have an auto scaling group as well. So let's have a look at auto scaling groups. Okay, so here is our auto scaling group for this Elastic Beanstalk environment. We've also have a load balancer as well. So let's have a look at that, see where that is. So we'll go to load balancers. And here we can see our AWS Elastic Beanstalk load balancer is there. There we go. So there's quite a lot of stuff that has been created for us. So what we can do now is simply clean it all up. So the best way to do that, or really the only way to do that properly, is to go back into the Elastic Beanstalk environment. And if we delete our environment from here, it will delete all of those resources for us. It will clean it up quite nicely for us. So I'm just going to go to Backspace Lab environment here again. We're going to go to Actions, and we're going to go to Terminate Environment. And we need to just type in the name of that environment. And terminate. So again, after quite a few minutes, our environment will be terminated, and all of those resources that were associated with that environment will also be deleted. As you can see, Elastic Beanstalk makes life a lot easier for us by automating all of the hard work in creating that back-end environment. So that brings us to the end of the lab. I hope you got a lot out of it, and I look forward to seeing you in the next one.